Hello, and welcome to Sleepy Science, a quiet corner of the universe, where your breath slows, your thoughts soften, and your sense of wonder gently wakes up. I'm so glad you're here, whether you've had a long day or a curious mind brought you here to drift into dreams. With soft science and subtle awe tonight, we'll journey not across galaxies or through time but inward, into the astonishing frontier of your own body, a landscape more alien and intricate than you might imagine, because beneath your skin, inside your bones, across your cells, and throughout your every breath, you carry secrets so strange and beautiful that they might just change the way you see yourself. Did you know you're glowing ever so slightly right now? That your gut has its own nervous system, often called a second brain? Or that your tongue could one day be used like a fingerprint to identify you? We'll explore how your bones are stronger than steel, how your body generates cancer cells every day and quietly fights them off, how your heart syncs to music, how your liver can regrow itself, and how your sleep position might influence how your brain cleans itself at night. It's a soft, curious journey into the mysteries of being alive. No pressure to stay awake. Just let your imagination wander while your body relaxes. And before we begin, I'd love to know, where in the world are you listening from? What time is it there? Are you bundled up under soft blankets? Or maybe winding down under the gentle hum of indoor light? Let me know in the comments. And if this kind of calm curiosity helps you rest, learn, or just feel better, please tap like and subscribe. It helps this peaceful little community grow. Now take a slow, grounding breath in and out. And let's begin our quiet descent into the marvels of your own biology, a soft, glowing, regenerating, memory-rich body you've known all your life, but may have never truly met until now. Your gut has its own brain. You might not realize it, but there's a voice inside you that doesn't speak in words, a system of awareness that hums beneath the surface of your thoughts, nestled deep in the soft tunnels of your abdomen, pulsing quietly with its own logic, its own rhythms, and its own kind of intelligence. Not metaphorical, not poetic, but biologically real. Your gut has its own brain, and it's been guiding more of your life than you ever imagined, silently shaping your moods, influencing your decisions, and regulating your well-being without ever needing your permission or attention. Because hidden within the walls of your digestive tract is a vast network of neurons, more than 100 million of them, arranged in a complex mesh that scientists call the enteric nervous system, a system so functionally autonomous that it can operate even if the spinal cord is severed, and so deeply wired into your emotions and behavior that it's sometimes referred to as your second brain. Though in many ways, it's not second at all, because this gut brain doesn't just manage digestion. It produces more than 90% of your body's serotonin, the neurotransmitter most closely associated with happiness and emotional regulation. And this means that the core of your mood, your emotional stability, even your capacity to feel joy, may be more intimately tied to your gut than to your thoughts, which flips the common belief that you think and then feel. In many cases, your gut feels first, and then your mind scrambles to catch up. And once you understand this, everything begins to shift. Anxiety, for instance, may not start in your head but in your belly, a vague sense of unease, a sudden clenching, a fluttering tension that seems irrational, but might be your gut interpreting a threat before your mind even becomes aware of it. Because evolutionarily speaking, your digestive system had to be smart, fast, and reactive long before the human brain became what it is today. And this ancient circuitry still operates like a survival compass, sensing danger in the environment, detecting pathogens in food, and even responding to emotional cues like stress, fear, or social tension, which explains why your stomach turns when you're nervous, why you lose your appetite when heartbroken, or why you feel gut instincts that you can't logically explain but often regret ignoring. And these instincts aren't illusions. They're feedback from a biological system processing real chemical data, real signals, real threats in real time. And what's more, The gut and the brain are constantly talking through a system called the gut-brain axis, a bidirectional communication network that includes neural pathways, hormonal messages, and even immune responses, with the vagus nerve acting as the high-speed highway between your head and your stomach, sending signals that affect not just digestion, but memory, emotional regulation, and even social behavior, meaning that your thoughts can change how your gut functions, and your gut can literally change how you think. And this relationship is so profound that some researchers are beginning to suggest that disorders like depression, anxiety, and even neurodegenerative diseases may have roots in gut dysfunction, particularly in the balance of microbes living inside you, because your gut is not just tissue and nerve. It is an ecosystem, a dense and dynamic rainforest of over 100 trillion microorganisms, including bacteria, fungi, viruses, and archaea, collectively known as the gut microbiome. And these microscopic inhabitants don't just digest your food, they synthesize vitamins, regulate inflammation, train your immune system, and send chemical messages that shape your behavior, memory, and mood. And the composition of this microbiome, the balance between helpful and harmful species, can be influenced by everything from your diet and stress levels to medications, sleep habits, and even the way you were born, whether by natural birth or C-section. And these early factors can set the stage for your lifelong gut health and, by extension, your mental health, immune resilience, and metabolic function, which is why emerging fields like psychobiotics, the study of using probiotics to influence mood and cognition, are gaining traction in modern neuroscience, because researchers are finding that certain strains of gut bacteria, like Lactobacillus rhamnosus or Bifidobacterium longum, can reduce symptoms of anxiety or even modulate GABA receptors in the brain, showing that the bacteria inside you might be shaping how safe you feel in the world, how much joy you can access, or how well you bounce back from emotional pain. And that raises a much deeper question. If so much of who you are, your preferences, your decisions, your stress responses, are influenced by invisible life forms living inside your intestines, then what part of you is really you? Is your personality a fixed thing, or a fluctuating pattern that emerges from this internal dialogue between your gut flora and your neural networks? Could changing your microbiome through diet, lifestyle, or environment actually change the trajectory of your life, the relationships you form, the thoughts you think, or the way you see yourself? The truth is, we're only beginning to understand the full implications of this system. But one thing is clear: the boundary between your mind and your body is far thinner than we've been taught. And your gut is not just a passive processor of food, it is a co-author of your experience, a vigilant gatekeeper of your inner world, and perhaps even a compass guide in you toward well-being or imbalance without ever needing words. And this is why practices like mindful eating, reducing chronic stress, prioritizing sleep, and nourishing your body with whole foods rich in fiber, polyphenols, and fermented nutrients are not just about weight or appearance. They are about giving your second brain the tools it needs to care for the first, and perhaps this is where the metaphor deepens. Because if your gut is its own brain, then maybe listening to it, truly listening, is not superstition or softness, but intelligence, a kind of biological wisdom that predates your language and outlives your opinions. A feeling-based radar for what is good, what is safe, what is real, and what is wrong. And maybe that's why children trust their bellies before they trust arguments, why trauma shows up in digestion before it shows up in dreams, and why healing, when it's real, often begins not in thought, but in the body, in the subtle shift from clenching to softening, from inflammation to calm, from disconnection to coherence. And so, perhaps the next time you feel your stomach tighten, or your appetite vanish, or a strange unease ripple through your torso without explanation, you might pause not to override it with logic, but to ask what this second brain knows that your first one hasn't yet caught up, because in this ancient architecture of nerves and microbes and chemical conversations lies a forgotten intelligence, not the kind that writes essays or solves equations, but the kind that knows when to run, when to stay, when to trust, and when to let go. The kind that keeps you alive when you're not thinking about survival, that guides you toward what nourishes and warns you from what harms. And in a world full of noise, algorithms, and artificial signals, maybe the most radical act of self-awareness is simply to listen to your gut, not as a cliché, but as a biological oracle that whispers the truth. Before your thoughts get in the way, you shed millions of skin cells daily. You might not have noticed, but right now, as you sit, breathe, or simply exist, tiny fragments of yourself are falling away, drifting into the air, collecting silently on your clothes, your sheets, your keyboard, and your floor. Because without any effort or awareness, your body is constantly shedding its outermost layer, releasing between 30,000 to 40,000 skin cells every minute, totaling nearly 50 million a day. And over the course of a single year, that loss adds up to about 8 pounds of dead skin. Enough to fill a small bag of flour, enough to account for a large portion of the dust in your home, enough to remind you that you are, in a very literal sense, constantly being erased and rewritten. And this process, called desquamation, isn't just a cosmetic detail or an occasional flake. It's a profound act of renewal encoded into your biology, a relentless cycle through which your body protects, repairs, and reinvents its outer boundary. Because your skin is not a static shell but a living, breathing, layered organ. In fact, the largest organ you have, one that weighs about 16% of your total body mass, and covers about 21 square feet on average. And this organ is in a constant state of flux, with its outer layer, the epidermis, completely replaced every 28 to 40 days. Meaning that the you of today, the you who feels the wind or touches a screen, is made of skin cells that didn't even exist a month ago. While the older versions of you, the older touch, the older interface with the world, have already crumbled into dust, scattered invisibly in rooms you've left behind. And while this might sound like a poetic image, it's firmly rooted in biology. Skin cells are born deep in the basal layer of the epidermis, pushed upward by new growth beneath them, flattening and hardening as they rise, filling with keratin and losing their nuclei until they form a protective, waterproof barrier, the stratum corneum, which is the part of you that interacts with the world. And yet, as soon as those cells reach the surface, they begin to die, loosen, and detach, sloughing off through friction, movement, or even the gentle flow of air. And you don't feel this happening because it's designed to be invisible, efficient, and continuous. A background process that maintains your biological integrity without distracting you from your life. But beneath its quiet operation lies a hidden network of immune cells, signaling molecules and biochemical alarms. Because your skin is more than a boundary. It's a communication hub, a surveillance system, and a chemical shield, monitoring your environment for pathogens, regulating temperature, synthesizing vitamin D, and even producing antimicrobial peptide, destined to fight off unseen invaders. And all of this happens while you go about your day unaware, even as your outermost self disintegrates in real time. And what's even more astonishing is that the dust created from your shed skin isn't inert. It becomes part of a larger ecological system, feeding microscopic mites, influencing indoor air quality, and even leaving behind a biological trace of your presence that can be detected long after you've gone, meaning that every room you've ever spent time in, every seat you've occupied, every pillow you've rested your head on contains evidence of your old selves. A kind of soft fingerprint made of forgotten cells, and scientists have even found ways to detect human DNA in house dust, allowing forensic analysts to identify individuals based solely on the skin particles they've unknowingly released. And this opens up philosophical questions that science alone can't answer. If you are constantly shedding who you were, if your physical boundary is never fixed, but always in motion, then what does it mean to be a self? What is continuity if the substance that makes you is always falling away? Can identity persist through constant cellular loss? And more practically, how much of what we see as clean or new is built on layers of the past, on remnants of people we can't see? When you lie down in bed, you're not just resting. You're sharing space with your former selves, particles of you that no longer feel but once did. And this isn't meant to be unsettling, but grounding, because the shedding of skin is not decay. It's transformation, a biological reminder that life is change, and that every moment you are becoming someone else, not symbolically, but cellularly. And this process also plays a critical role in healing. When your skin is injured, your body ramps up production of new cells, accelerating the cycle of regeneration, sending immune cells to clear debris and signal repair. And in cases like sunburn, this shedding becomes visibly dramatic, peeling, flaking, stinging. Not because your body is malfunctioning, but because it's protecting you from deeper damage, replacing compromised cells with fresh ones, prioritizing survival over appearance. And it's this principle that underlies conditions like psoriasis or eczema, where the balance of shedding and renewal becomes disrupted, leading to rapid overproduction or inflammation, and showing that this process, while automatic, is deeply sensitive to internal and external cues, including stress, diet, and immune function. And then there's the deeper metaphor, the way skin mirrors emotional experience. We speak of getting under someone's skin, of being thin, skinned, or thick, skinned, of wanting to shed the past. And these aren't just linguistic accidents. They reflect a biological truth that your skin is both boundary and mirror, both protector and communicator, and the act of shedding, while physical, resonates on a psychological level as well, because there are parts of you, beliefs, habits, wounds, that no longer serve you. And just like the dead skin cells you lose each day, those parts can be released. Not all at once, not always with ease, but slowly, quietly, through the friction of daily life, through time, reflection, and self-awareness. And perhaps that's what healing really is. Not a dramatic transformation, but a cellular whisper, a steady letting go of what's no longer living in you. And when you understand this, the everyday becomes sacred. The breeze becomes a sculptor shaping your surface. Your pillow becomes a witness to the shedding of pain and joy alike. And you begin to notice that nothing about you is permanent, but everything is connected. That even in loss there is renewal, and in every cell that falls, there is room for something new to grow. And maybe that's what makes skin so miraculous. It never holds on too long, it never clings to what's dead. It simply renews, quietly, ceaselessly, faithfully, as if to remind you that your story isn't fixed, your past isn't your prison. And every morning, you wake up not just as who you were, but as someone already becoming someone else. Your bones are stronger than steel per weight. You may not feel like it, but inside you lives an architectural masterpiece, one so quietly resilient and meticulously engineered that it outperforms some of the strongest materials on Earth. Because your bones, those pale, silent structures that hold your form together, are, pound for pound, stronger than steel. Not in the sense of raw durability, under crushing force, but in their remarkable combination of strength, lightness, flexibility, and regenerative intelligence. And once you understand what your skeletal system truly is, not just a rigid framework, but a living, breathing, adapting matrix of cellular activity and biomechanical wonder, you begin to see your body in a very different light, not as a fragile vessel, but as a quiet fortress, grown from within. And it starts with composition. Your bones are made primarily of a composite material, about 60% mineral, mostly calcium phosphate, giving them hardness, 30% organic matrix, mostly collagen, giving them flexibility, and 10% water. And this delicate balance allows them to be stiff enough to support your weight and withstand massive forces, yet elastic enough to absorb shock without shattering, much like the way reinforced concrete is made stronger by steel rods embedded within it. Except in your case, the rods and concrete are biologically grown and self-repairing, which is something no manufactured material can yet replicate. In terms of tensile strength, compact bone, the dense outer layer found in long bones like the femur or humerus, can withstand forces of about 130 megapascals, while steel sits around 250 megapascals. And yet, when you compare them by weight, bone achieves greater efficiency, offering roughly 5 times the strength to weight ratio of steel, meaning that ounce for ounce, your skeleton is a superior structure for carrying its own mass, especially when it's constantly adjusting to load, stress, and environmental pressure in a way that steel never could. But the real marvel isn't just mechanical. It's biological, because bones are not dead scaffolding, but dynamic tissues in constant flux, continuously broken down and rebuilt by specialized cells called osteoclasts and osteoblasts, operating in a complex hormonal feedback loop, influenced by your activity level, nutrient intake, and even your emotional state. And this constant remodeling ensures that your skeleton is never more than a decade old. You carry a full-grown adult body whose framework has been quietly renewed, reabsorbed, and remade cell by cell, which is both astonishing and deeply symbolic. You are not as solid or static as you think, and strength doesn't come from permanence, but from intelligent change. Consider also the design of specific bones. The femur, your thigh bone, is capable of supporting 30 times your body weight when compressed, while the spine, with its intricate curvature and intervertebral discs, functions not like a stack of bricks, but like a living spring, distributing weight and absorbing motion as you walk, twist, or sit. And the skull, with its vault-like shape and multiple fused plates, protects the most delicate part of you, your brain, without weighing you down, balancing defense and mobility with eerie precision. And then there's the honeycomb, like internal structure of cancellous, or spongy bone, found at the ends of long bones and inside vertebrae, which mimics fractal geometry, a pattern of repeating structures across scales, to achieve maximum strength with minimal mass. And engineers studying this structure have borrowed from it to create lightweight aerospace materials and impact-resistant equipment. A branch of science known as biomimicry, where nature's blueprints become the inspiration for human innovation. And your bones, with their microscopic arches and bridges, are among its most studied subjects. But the genius of your skeleton doesn't end at structure. It also houses your blood factory, the bone marrow, where red and white blood cells are produced in the millions every second, quietly fueling your entire circulatory and immune systems from deep within your hollow bones. And in this way, your skeleton is not just what supports you physically, it also generates the very cells that carry oxygen, fight infection, and form the immune memory that keeps you alive. Meaning that every breath you take, every heartbeat, every healing wound, owes something to the inner workings of your bones. Even more surprising is the fact that bones are endocrine organs. They release hormones like osteocalcin, which plays roles in energy metabolism, male fertility, and cognitive function, showing us that bones influence far more than movement or posture. They reach into your behavior, your memory, even your blood sugar regulation. And these discoveries are recent, still unfolding, reminding us how much of the body's intelligence has been overlooked or misunderstood. And perhaps this is why breaking a bone is such a profound experience. Not just painful, but disorienting. Because you become abruptly aware of what you usually take for granted, the silent, ever-present strength that holds you up, and the astonishing speed with which your body responds to damage, sending in stem cells, rebuilding collagen scaffolds, mineralizing new tissue in phases, such that within weeks or months, depending on age and health, what was once fractured can become whole again, sometimes stronger than before, in a phenomenon called bone remodeling. And this is why astronauts returning from zero gravity must undergo months of weight-bearing therapy, because without regular mechanical stress, bones weaken, their density decreases, and their architecture becomes porous. A condition echoed here on Earth in osteoporosis, especially among the aging, where the balance of bone resorption and formation tips dangerously toward loss. This teaches us something both clinical and philosophical. Strength must be used to be maintained. And just like muscles, bones respond to how you live, to whether you move, lift, run, rest, or resist. And in this sense, the story of your skeleton is also the story of your habits, your resilience, and your engagement with the world around you. And then comes the poetic angle, the quiet metaphor inside your frame. Bones are what remain when everything else is gone. The last trace of who you were, the part of you that endures fire, time, and burial. And yet, even as they signify permanence in death, they embody change in life, growing from soft cartilage in the womb, fusing at over 300 points in infancy into 206 adult bones, adapting their shape through childhood injuries, bending subtly in youth and thinning gradually with age, responding all the while to the unique way you inhabit your life. And perhaps that's the most beautiful truth of all, that the very core of your being is not made of something invincible, but of something wise, flexible, and responsive. That your deepest strength is not a wall, but a dance between pressure and adaptation, form and function, loss and renewal. And the more you learn to respect that, by nourishing your bones with calcium, vitamin D, movement, and rest, the more you can live in harmony with your own architecture, not fearing its limits, but marveling at its brilliance, and remembering that you are not weak just because you can break. You are strong because you are constantly rebuilding. You glow in the dark slightly. There's something quietly surreal about realizing that your body right now is glowing. Not in a way that lights up a dark room or draws attention from across the street, but in a way that's subtle, invisible to your eyes, yet undeniably real, because every human being emits a faint light known as bioluminescence, a soft, continuous glow that pulses gently from the surface of your skin, peaking and fading in rhythms you never notice, as if your body is a silent candle flickering beneath the noise of visible light. And though this phenomenon might sound like fantasy, it has been confirmed by science. Using ultrasensitive cameras, researchers have captured images of the body's natural light emissions, showing that humans radiate photons, particularly from the face, chest, and hands, in patterns that shift with the time of day, strongest in the late afternoon and weakest in the morning, a diurnal cycle that appears to echo metabolic activity and oxidative stress. And yet, this light is about 1,000 times weaker than the threshold of human vision, which is why you've never seen yourself shine, and why this constant glow feels more like a metaphor than a measurement. But it is measurable, and it is true. You are quite literally a source of light. To understand how this works, you have to dive into the molecular theater happening inside your cells, particularly the process of aerobic respiration, where mitochondria, the energy factories of your body, break down nutrients like glucose and fats, producing ATP, the chemical currency of life. And during this process, small amounts of unstable oxygen molecules, or reactive oxygen species, are generated as byproducts. And while these rows are essential in moderation, helping regulate signaling and immune responses, they can also react with lipids, proteins, and DNA in a phenomenon called oxidative stress. And it's during some of these reactions, especially lipid peroxidation, that tiny flashes of light are released, photons escaping as a result of excited molecules returning to their ground state, a process known as ultra-weak photon emission. And it's this light, this biochemical shimmer, that surrounds you constantly, even in your sleep. The fact that our bodies glow raises deeper questions about perception and biology. What else exists in us, around us, that we're not equipped to detect? Our visual spectrum is narrow, limited to wavelengths between roughly 400 and 700 nanometers, leaving out vast territories of ultraviolet and infrared, where many creatures thrive. Snakes see body heat. Bees see ultraviolet patterns on flowers. Some deep-sea creatures communicate with light we cannot fathom. And yet we walk through the world believing that what we see is all there is, when in reality, we are constantly immersed in hidden currents of energy and information. Your glow, however faint, is part of that invisible world. Not mystical, but physical. Not symbolic, but scientific. And though we can't see it, it responds to your physiology. Studies have shown that people who are stressed, ill, or have certain skin conditions emit different photon patterns, suggesting that bioluminescence could one day be used in non-invasive diagnostics, allowing doctors to see oxidative stress before symptoms emerge. A kind of glowing fingerprint of internal imbalance. And what's more fascinating is that different areas of the body emit light in different intensities. The cheeks, forehead, and neck are brighter than the torso. And this isn't random, but tied to variations in mitochondrial density and metabolic rate, meaning that your face, quite literally, broadcasts your inner activity. You radiate light most strongly where emotion, expression, and attention tend to center, as if the body already knew where to send the signal. And perhaps what's most poetic is that this glow is not tied to the conscious self. You don't control it, you can't fake it, and you can't stop it. It is a byproduct of being alive, of metabolizing the world, of existing as a system in motion, and this leads to a humbling thought. Even when you feel unseen, unimportant, or small, your body is quietly testifying otherwise. You are glowing, always, broadcasting your presence in the language of light. And if you extend this idea further, into the realm of philosophy or emotion, the symbolism becomes rich. We speak of people lighting up a room, of someone having a radiant smile or inner glow. And while these phrases are often dismissed as metaphor, they may be rooted in an ancient intuitive awareness that living beings emit more than heat or breath. We emanate something subtler, more luminous, and perhaps more meaningful than we've been taught to believe. Your glow is also tied to rhythms. It follows circadian patterns, fluctuating with time of day and potentially linked to melatonin production, oxidative cycles, and hormonal shifts. And this reinforces a deeper principle. Your body is not a static object, but a pulsating system of waves, emissions, fields, and flows, operating in time with forces you cannot see, but are deeply shaped by. And in this way, your bioluminescence becomes a clock, as well as a mirror, reflecting the unseen states of your cells, and aligning you with a biological rhythm older than thought itself. And though this glow is imperceptible to the naked eye, some believe that animals, especially those more attuned to ultraviolet or infrared ranges, might detect subtle cues from our light emissions, which raises compelling possibilities. Could a dog's intuition, a baby's gaze, or even a stranger's inexplicable connection be influenced by the invisible light you carry? Could this be one of the reasons first impressions feel so visceral, so unspoken, as if part of us is reading signals we don't consciously understand? The science is still young, but the questions are vast, and they lead us to wonder whether perception is just about sight or something far more layered, where the body itself speaks in photons, vibrations, and frequencies. And beyond biology, there's something comforting in knowing that you shine, even slightly, even silently. Even when you feel dim inside, your glow is not dependent on mood or confidence or success. It is the physics of metabolism, the poetry of respiration, the echo of cellular life, pushing on in the dark. And maybe that's the deeper metaphor we've missed all along. That even in your quietest, lowest, most invisible moments, you are still emitting light, still participating in the radiant flow of existence, still part of the luminous story of being alive in a universe stitched together by energy and reaction and breath. So the next time you're in a dark room, sitting alone or lying in bed, wondering if you matter, wondering if anything you've done has left a mark, remember this: your body is glowing, your skin is whispering photons into the silence, and somewhere, whether measured by instruments or simply felt in the presence of others, that glow carries meaning. Not because it's bright, but because it's real. Your stomach lining regenerates weekly. You might never think about it, But right now, at this very moment, the lining of your stomach, that soft, unseen barrier between you and the caustic chemicals required to digest your food, is quietly dissolving itself and building itself back up again in an endless, astonishing cycle of self-renewal that repeats roughly every 5 to 7 days. Because the environment inside your stomach is one of the harshest biological terrains in the human body, a place so acidic that it could dissolve metal over time, where pH levels can drop as low as 1.5 to 2. And yet somehow, the delicate tissues that line this chamber manage not only to survive this internal acid bath, but to thrive in it, adapting, shedding, regenerating, and protecting you in a continuous loop of destruction and rebirth that most people never even realize is happening. And this regenerative feat isn't a minor biological footnote, but a vital, life-saving process, without which you couldn't survive more than a few days, because the cells lining your stomach are under constant assault, not just from hydrochloric acid and digestive enzymes like pepsin, but also from friction, bacteria, inflammation, and even stress hormones, all of which threaten to erode the thin layer of protection that separates your living tissue from your own internal chemical arsenal, which means that your stomach's survival strategy is one of constant renewal. A conveyor belt of epithelial cells that are born deep in the gastric glands migrate upward toward the lumen where digestion takes place, and then die off, sloughing away, replaced by fresh ones before any lasting damage can occur. A process so efficient and rhythmic that it borders on the miraculous. And yet it is orchestrated by a precise ballet of cellular signaling, stem cell activity, and genetic programming that scientists are only beginning to fully understand. This process is driven primarily by gastric stem cells, specialized cells tucked into niches within the gastric pits, capable of differentiating into various types of stomach cells: mucus, secreting cells, acid, producing parietal cells, enzyme, producing chief cells, and more, each with a role in maintaining balance, digestion, and defense. And the speed of turnover is necessary because the mucus layer coating the stomach, which helps buffer the acid, is itself fragile and thin, requiring constant replenishment along with the cells beneath it. And when this process is disrupted due to infection, medication, chronic stress, or autoimmune reactions, the results can be devastating: ulcers, gastritis, bleeding, and in some cases, cellular mutations that may lead to cancer, which reminds us that the very resilience of the stomach is both its strength and its vulnerability, because it must walk a fine line between self-protection and self-digestion, balancing destruction and creation in the most literal way. And if you pause to think about this, it becomes strangely poetic, that within you is a place that exists in perpetual volatility, a chamber where no single cell survives more than a few days, and yet the structure remains whole, like a sandcastle constantly being swept away and reformed by an invisible tide. And this rhythm doesn't stop when you sleep or rest or feel still. It continues through every hour, every meal, every moment of silence or stress, making sure that your inner wall is never breached, that your organs are never burned from the inside out, that your body remains intact, despite the corrosive processes it relies on to survive. What's even more compelling is that your stomach's resilience isn't isolated. It's influenced by what you eat, how you feel, and the signals your brain sends in response to your environment. Because the gut-brain axis is real and direct, meaning that anxiety, anger, or fear can alter acid secretion, slow or speed digestion, and affect the rate at which your stomach lining regenerates, a phenomenon that helps explain why chronic stress is linked to ulcers and GI disorders, and why calming practices like mindfulness, deep breathing, and even laughter can positively impact gastrointestinal health, not metaphorically, but through measurable biochemical changes. And then there's the role of prostaglandins, hormone-like substances that play a critical part in protecting the stomach lining, stimulating mucus and bicarbonate secretion, while promoting blood flow and cell regeneration. which is why nonsteroidal anti-inflammatory drugs, SEDs, like ibuprofen, can be dangerous in high doses or over long periods. They inhibit prostaglandin production, reducing your stomach's natural defenses and leaving it more susceptible to injury. Another reminder that even medications intended to help can, if misused, turn against the very systems they aim to support. And if all of this seems mechanical or remote, consider the fact that every meal you've ever eaten, every bite of birthday cake, every bitter sip of coffee, every late-night snack has triggered this invisible dance of breakdown and renewal inside you. And your body has handled it all without complaint, adapting its inner lining to handle spice, sugar, acidity, texture, and timing, learning from patterns and modifying enzyme levels and cell turnover rates in response to your habits. Which means that the stomach isn't just a passive organ, it's a learning system, a responsive, adaptive, evolving environment that customizes itself to the life you live. And that fact alone should be enough to inspire a kind of reverence for this overlooked organ that works harder, faster, and with more risk than almost any other part of your body. And perhaps this is where the deeper meaning lies. That within the quiet center of your body is a reminder that true strength is not about rigidity or permanence, but about the ability to withstand destruction, to renew, to rise again even when the environment is hostile and the damage is constant. And that the systems within you are not only surviving, they are creating, recreating, adapting, evolving in silence, never asking for your attention, never demanding recognition, simply doing what they must to keep you alive, whole, and moving forward. And so the next time you feel fragile or overwhelmed, remember this: there is a part of you that burns and heals itself in the same breath, that dies and is reborn every single week, that holds your body together with nothing but cells, time, and intelligence. And if your stomach can do that without rest, perhaps you too are capable of more resilience than you know, of rebuilding the parts of yourself that feel worn thin, of surviving not because nothing touches you, but because you have learned, like your own cells have learned, to renew from within. You make a liter of mucus daily. You might not like the sound of it. In fact, you might instinctively wrinkle your nose. But every single day, without realizing it, your body produces around 1 full liter of mucus, a translucent, gel-like substance that often gets dismissed as something gross, annoying, or unworthy of attention, when in truth, it's one of the most essential and underappreciated players in your survival, working non-stop behind the scenes to protect you from the moment you wake to the moment you sleep. And even while you dream, coating, filtering, signaling, and defending nearly every entry point of your body, including your nose, throat, lungs, stomach, eyes, intestines, and even reproductive organs, not as an afterthought, but as a frontline defense, a molecular shield woven from water, glycoproteins, antibodies, enzymes, and lipids, all calibrated to form a complex dynamic barrier that adapts to temperature, threat level, hydration, and infection. And the fact that you make an entire bottle of it daily, enough to fill a small carton of milk, is not a sign of dysfunction, but of health. Because mucus is your first and often best defense against the outside world, catching pathogens before they can enter your bloodstream, trapping dust, smoke, pollen, and pollutants before they irritate your lungs, and lubricating tissues to prevent friction, tears, or dehydration. And yet most people only notice it when something goes wrong, when they're sick, congested, sneezing, or coughing. When the mucus becomes thick or discolored, leading to the false assumption that it's the illness itself, when in fact, it's the body's response to the illness. A sign that your immune system is engaged, actively neutralizing invaders, and flushing them out through whatever means it can. Whether that's sneezing, nose, blowing, coughing, or swallowing. And it's not just a passive substance either. It's an active biochemical matrix, home to mucins, large, sugar-coated proteins that give mucus its slippery texture, as well as defensins and lysozymes, that literally break down bacterial cell walls, making mucus both a physical barrier and a chemical weapon. And within your respiratory tract, alone, tiny cilia, microscopic hair-like structures, beat rhythmically in a coordinated wave to move mucus upward and out, like a conveyor belt of waste removal that silently clears your lungs of invaders and debris over and over again. So you don't have to think about it. In the gastrointestinal tract, mucus has yet another role. It forms a lubricated lining over the epithelium, shielding your tissues from the acidic and enzymatic onslaught of digestion, ensuring that food is broken down without your own tissues being digested along with it. And beyond that, it acts as a gatekeeper for the microbiome, helping manage which microbes get close to the intestinal wall and which are kept at a safer distance. Because the body doesn't just host bacteria, it manages them through mucus, using it to negotiate the space between self and non-self, between cooperation and invasion. And perhaps most fascinating of all is that mucus is not a single thing. It's custom, formulated, depending on location and context, with nasal mucus differing in composition and pH from vaginal mucus, which itself changes viscosity throughout the menstrual cycle in order to facilitate or inhibit sperm motility depending on the body's reproductive intentions. And cervical mucus has even been shown to filter out sperm with DNA damage, acting as a literal quality control barrier for genetic material. A breathtaking example of biochemical discernment happening silently, far below conscious awareness. And the way mucus changes in sickness is not accidental either. When you have a cold, for example, your body produces more cytokines and histamines, which increase vascular permeability and mucus production in the nasal passages, helping flush out pathogens more quickly. And the green or yellow color, often associated with infection, isn't because mucus itself is inherently colored, but because of an enzyme called myeloperoxidase released by neutrophils, a type of white blood cell, as they attack bacteria, meaning that colored mucus is not a sign of bacterial overgrowth per se, but of your immune response in action. And this brings us to the uncomfortable truth that swallowing mucus, which happens constantly, is not gross or problematic, but biologically strategic, as it allows waste material, dust and neutralized pathogens to be transported safely to the stomach, where gastric acid and digestive enzymes can destroy them completely, making mucus a delivery system for elimination, not just a passive sponge. And in recent years, researchers have even discovered that the mucus layer in your gut may play a role in mental health, with disruptions in its thickness or composition linked to inflammation, leaky gut syndrome, and even anxiety or depression via the gut brain axis and immune signaling pathways, which suggests that taking care of your mucus through hydration, nutrition, and avoiding chronic stress may be more important than we've been led to believe, and that neglecting this invisible layer can have consequences far beyond congestion. In the field of biotechnology, mucus is now being explored as a platform for drug delivery, with researchers studying how to engineer nanoparticles or medications that can penetrate mucus barriers effectively without being swept away. And mucus-derived compounds are being investigated for their antimicrobial and antiviral properties, particularly in an age where antibiotic resistance is on the rise, offering a natural template for defense strategies that are already millions of years old, and yet refined enough to function inside the sensitive tissues of the human body. And then, of course, there's the philosophical layer, the idea that we are constantly coated in something that protects us, adapts to us, and responds to our environment without our permission or awareness. Something that doesn't require us to act tough or be conscious, but simply flows into place as a buffer between the chaos of the world and the vulnerability of the self. And perhaps that's why we recoil from the idea of mucus, not just because it's sticky or inconvenient, but because it reminds us that we are soft, permeable, easily invaded, and in need of constant protection. And in a culture that worships cleanliness, boundaries, and control, The idea of producing a liter of slippery organic goo every day just to keep from falling apart feels undignified. When in truth, it's one of the most dignified systems we possess. A humble, selfless, never-resting defense network that absorbs punishment, endures insult, and vanishes without credit. And maybe that's the lesson hidden in the mucus we try to ignore. That strength is not always loud or rigid or visible. That resilience is sometimes slimy, translucent, and patient. And that the body's wisdom shows up not just in muscles or willpower, but in the layers we never see. Layers that hold us together in silence. Your body makes cancer cells all the time. You might believe that cancer is something that only appears when something has gone wrong. A rare mutation, an external trigger, a stroke of bad luck. But the deeper truth is far more unsettling and strangely more hopeful. Your body is creating cancerous cells all the time. Right now, even in tiny corners of your tissues, where a single cell divides a little too fast, copies its DNA with a small error, ignores the usual stop signals, and quietly begins to replicate without permission. And yet, despite this ongoing production of potentially dangerous cells, you don't have cancer. Not because it never starts, and self-correction, that intercept and destroy these rogue cells before they ever become a threat, functioning with such precision and quiet determination that you never even know a battle was fought. Every day, your immune system scans your tissues for abnormalities. Cells that grow irregularly, that express strange proteins on their surface, or that evade apoptosis, program cell death. And when found, these cells are flagged, targeted, and removed by specialized warriors, like natural killer cells, cytotoxic T cells, and macrophages, acting like microscopic assassins, trained to preserve the integrity of your biological identity by eliminating the seeds of chaos before they can take root. And this constant dance between mutation and surveillance is not a fluke. It is your baseline state, the price of being alive, and made of trillions of cells that must divide, renew, and rebuild across time. Because every cell division carries the risk of error, and in the vast molecular library of your DNA, even a single typo in a critical gene, such as a tumor suppressor like TP53, or an oncogene like RAS, can start a cascade that leads toward uncontrolled growth. Yet the miracle is how often this doesn't happen. How rarely cancer survives the gauntlet of internal defenses. How many thousands of microcancers are extinguished inside you before they ever leave a mark. And this changes the story we usually tell about cancer, from a rare invasion to a common uprising that's almost always defeated. Scientists have known for years that the body harbors precancerous lesions long before disease ever becomes visible. In breast tissue, prostate tissue, lungs, skin, even the blood. And in many autopsies of people who died of unrelated causes, small clusters of mutated cells are found that never grew, never spread, never harmed, because the immune system did its job silently, and the cells either self-destructed or were destroyed by immune surveillance mechanisms like immunoediting, a process in which abnormal cells are first detected elimination, then shaped by immune pressure to either hide equilibrium or escape. And whether they manage to escape often depends on how healthy your immune system is, how much chronic inflammation or stress is present, and even how your body's unique epigenetic signatures interact with environmental exposures. And there's something profoundly sobering about this, that cancer is not an other. Not a foreign invasion, but a potential that lives inside you always, a reflection of the same power that allows you to heal, regenerate, and grow, the ability to multiply cells, to evolve at the molecular level, to adapt and self-renew. And it is only when that power becomes misaligned, unchecked, or escapes detection that it turns against you, not out of malice, but out of entropy, noise, and time. Because evolution is messy, and biology is probabilistic, not perfect, and the system you live in is one that constantly balances creation with destruction, risk with repair, error with oversight. And this leads us to an even more remarkable realization. that you are not healthy because nothing ever goes wrong, but because so much is caught, repaired, neutralized, and deleted before it ever has a chance to hurt you. That your health is not the absence of failure, but the presence of quiet, constant, invisible resilience, responsive intelligence, one that rewrites itself based on experience, remembers past threats through T-cell memory, adapts to new mutations through somatic hypermutation in B cells, and even teaches itself to recognize new forms of cellular betrayal. And this is where modern medicine has begun to catch up, not just with treating cancer after it spreads, but with empowering the immune system to do what it already does best, through immunotherapies that enhance T-cell targeting, checkpoint inhibitors that release the immune brakes, and mRNA technologies that train the body to recognize the signs of malignancy before it grows too strong, transforming treatment into a kind of internal education system, teaching the body to defend itself with greater clarity and speed. And yet, despite these advancements, the true marvel is what your body already does every day without any intervention, filtering trillions of cellular actions, monitoring for missteps, cleaning up broken or misfolded proteins through proteasomes and lysosomes, repairing DNA with enzymes like DNA polymerase and ligase, and constantly triggering apoptosis in cells that start to stray from their intended function, meaning that every hour of every day, you are walking through a minefield of potential cancers and emerging unscathed not by luck, but by architecture, by design, by thousands of generations of evolutionary refinement that have produced an organism capable of surviving itself. And if this doesn't fill you with awe, consider that many animals lack this level of surveillance, and some, like elephants, have evolved extra copies of tumor suppressor genes, like TP53, perhaps as a biological answer to their massive cell counts, while others, like naked mole rats, have unique molecular tricks that prevent cell overgrowth entirely. And in humans, this interplay between genetic vulnerability, environmental exposure, and immune strength continues to be studied, with the growing realization that lifestyle factors, sleep, nutrition, stress, exposure to toxins, do not create or prevent cancer directly, but influence the battlefield, determining how quickly immune forces can respond, how much inflammation is present, how well surveillance systems operate, and how often dangerous cells are caught early or allowed to grow in secret. Which brings us to the philosophical core of it all, that to live is to risk, that to grow is to gamble, and that your very capacity to repair is born from the same instability that sometimes produces threat. And yet you continue, you regenerate, you renew, because your body is a system not of perfection, but of balance. And in that balance lies a lesson about resilience, that surviving isn't about avoiding mutation or change, but about meeting it with readiness, awareness, and the quiet strength to correct what needs correcting before it becomes something else. So the next time you hear the word cancer, don't think of it only as a disease that appears from nowhere, but as a shadow that flickers constantly at the edge of every cell's life, usually harmless, often defeated, always present. And realize that what makes you strong is not that you never generate danger, but that you are built to face it, to find it, and to overcome it, even when you're not aware it's happening. And that might be the most extraordinary truth of all. The liver can regrow itself. You might never think twice about your liver until something goes wrong, until you feel a dull ache under your ribs, or blood tests come back with odd numbers, or someone you love is told theirs is failing. And yet, behind the scenes, your liver is doing something truly extraordinary every single day, something no other internal organ in your body can do with such scale or resilience. It can regrow itself, not just repair minor damage, but actually regenerate entire portions of lost tissue. And it can do so over and over again, silently, without you even noticing, making it one of the most astonishingly adaptive structures in human biology. Not because it's immune to harm, but because it was designed to survive harm, to endure toxins, injury, and even surgical removal, with a kind of cellular determination that borders on science fiction, a fact that ancient healers may have intuitively understood. As early as 4,000 years ago, When the myth of Prometheus was first told, the story of a titan who was punished by having his liver eaten each day by an ear, gull, only to have it grow back again overnight. A tale that might have sounded metaphorical, but turns out to be biologically true, because the liver, unlike the heart or kidneys or brain, contains an incredibly dense population of specialized cells called hepatocytes, which are not only metabolically active but capable of re-entering the cell cycle in response to injury, dividing and differentiating to replace lost tissue with astonishing speed and accuracy. And the implications of this are profound. If you were to lose up to 70% of your liver through accident or surgery, the remaining 30% could regrow the rest, not by forming scar or static tissue, but by rebuilding functional, vascularized, operational liver mass, often within weeks, sometimes within days. And this regrowth is not random chaos, but a highly choreographed biological symphony, involving a precise interplay of growth factors, like hepatocyte growth factor, epidermal growth factor, transforming growth factor, alpha, and cytokines like interleukin-6, all released in waves that trigger, accelerate, and then eventually suppress cell division once the ideal size is restored, ensuring that the regeneration doesn't spiral into uncontrolled growth. A balance that's breathtaking in its elegance, especially considering the liver's wide portfolio of responsibilities, from detoxifying blood, breaking down medications, metabolizing hormones, producing bile for digestion, synthesizing essential proteins like albumin and clotting factors, to storing glycogen and fat-soluble vitamins, filtering out pathogens, and even helping regulate your body's cholesterol and iron levels, all of which it continues to do, even as it's rebuilding itself. Meaning the liver is not only regenerative, but resilient under load, capable of multitasking life, sustaining functions even during its own repair. And yet, like all things powerful, it has limits. While it can recover from injury, repeated or chronic damage, like that from excessive alcohol, hepatitis infection, or fatty liver disease, can eventually overwhelm its regenerative abilities, leading to fibrosis, cirrhosis, or irreversible architectural distortion, not because the cells give up, but because the scaffolding around them becomes too scarred to support further healing. A reminder that regeneration is not immunity, but capacity, and that capacity can be exhausted if harm outpaces repair. Still, this potential for regrowth has inspired modern medicine in remarkable ways. Living liver donations are now possible, where one person donates a portion of their liver to another, and both can regenerate their halves into full functional organs again. A surgical miracle only possible because of this one organ's unique blueprint. And in research labs around the world, scientists are studying how liver regeneration might help inform stem cell therapies, tissue engineering, and even cancer treatment. Because understanding how the liver knows when and how to grow, and when to stop, holds keys to unlocking regenerative medicine far beyond the abdomen. And here's something even more striking. This ability to regrow doesn't come from some exotic or mysterious trait. It comes from evolutionary pressure, from the reality that the liver has always been a frontline organ, the first to receive blood from the digestive tract via the portal vein, and therefore the first to be exposed to toxins, pathogens, and dietary excesses. So evolution favored an organ that could take a hit and rebuild fast, that could be damaged without fatal consequence, that could self-renew in an environment where destruction was not just likely but inevitable. And, in a way, the liver's regeneration becomes a metaphor for you, for your ability to bounce back, to be wounded without being broken, to be scarred without being stopped, to lose something essential and still grow into wholeness again. Not by forgetting what was lost, but by rebuilding with intention. And maybe that's why this hidden organ, tucked beneath your ribs, hums so quietly with strength. Because it is proof that healing is not only possible but natural, not only likely but expected, and that you were never designed to be fragile, but to be repairable. And in a time when so much of life feels irreversible, heartbreaks, failures, damage, regret. The liver reminds you that biological systems can forgive, that tissue can grow anew, that functions can be restored, and that life, at its deepest cellular levels, is not about perfection, but resilience. Not about avoiding harm, but about carrying the wisdom to recover from it. And so the next time you hear the word liver, don't think only of alcohol or lab tests, or the grey organ in medical diagrams. Think of regeneration, of second chances, of inner blueprints for recovery that run deeper than your memory, of an organ that knows how to rebuild you, even when you don't know how to rebuild yourself. And let that knowledge stay with you. A quiet strength beneath your ribs that never stops trying, no matter what it has lost. You can survive with one kidney. You've probably gone most of your life never thinking about your kidneys. Those two bean-shaped, fist-sized organs, quietly tucked deep in your lower back, hidden behind ribs, out of sight, out of mind. And yet, right now, they are filtering your blood every single minute, without pause, without thanks, without a sound, removing waste, balancing electrolytes, regulating fluid, maintaining your blood pressure, and even managing the hormones that influence how you make red blood cells, or how your bones maintain strength. And the incredible thing, the truly humbling part, is that you only really need one to live a full, healthy, normal life, because the kidneys, while designed as a pair, come with built-in redundancy so profound that half the system can still do almost everything the full system does. And that fact becomes more extraordinary the deeper you go. Because your two kidneys process about 50 gallons of blood every single day, filtering out excess water, urea, creatinine, and countless other waste products, producing around 1.5 liters of urine daily. And if you were to lose one, whether by injury, illness, or organ donation, the remaining kidney doesn't just carry on passively, it actually adapts, hypertrophies, grows larger, increases its individual nephrons' filtration rate, and recalibrates itself to handle the increased workload. Almost as if it knows the stakes have changed, and it does all this without diminishing your quality of life, without making you feel different, without even requiring medication or compensation in most cases, which reveals something powerful about your biology, that you were never built for fragility, but for backup, for resilience, for continuity even in the face of loss. And while the idea of surviving with one kidney might seem like a medical curiosity, it's actually quite common. There are thousands of people walking around with just one kidney who either donated the other out of love, were born with a single functioning kidney, or had one removed due to cancer, trauma, or congenital disease. And most of them live entirely normal lives, playing sports, having children, eating well, aging without issue, which says something even more profound, that survival doesn't always require symmetry, and that function matters more than form. And this fact has driven modern organ transplant science into ethical and medical revolutions. Because for a long time, organ donation was limited to cadavers. But once we understood that a healthy person could safely donate one kidney and keep living without complications, it unlocked a new world of living donation, allowing one person's choice to give away half their renal system to completely transform someone else's life. Someone on dialysis, who spends hours a week having their blood cleaned artificially. Someone whose kidneys have failed slowly over time, or suddenly due to autoimmune disease or infection. Someone whose body could no longer clear waste or regulate blood pressure. And in giving one kidney, the donor becomes a living bridge between two stories, carrying a weight most people never see. Because donating a kidney is not just a surgical act, it's a biological trust fall, a leap of cellular faith, and the recipient carries that gift for the rest of their life, knowing their survival came from someone else's sacrifice. And this regenerative partnership isn't magic, it's science rooted in anatomy and adaptation. And yet it feels poetic that your body contains an organ capable of standing alone when needed, of expanding its capabilities when pressed, of holding the line when half the system is gone, and it does so through a marvelously efficient unit called the nephron, of which each kidney contains around 1 million. And these nephrons are tiny filtering factories, composed of glomeruli and tubules, working together to reabsorb water, conserve electrolytes, excrete toxins, and fine-tune your inner chemistry every minute of your life, responding to hydration levels, blood volume, arterial pressure, and even hormonal cues like antidiuretic hormone and aldosterone, which adjust how much water is retained or excreted. And when one kidney is removed, the remaining one doesn't grow new nephrons, but makes each existing one work harder, increasing blood flow and filtration rate, demonstrating an elegant form of compensatory hypertrophy that echoes a kind of biological loyalty. If one side fails, the other steps up without complaint. And while long-term studies show that most people with a single kidney live normal lifespans, with few, if any, complications, it's also true that care matters. Avoiding certain medications like NSAIDs that stress the kidneys, staying hydrated, monitoring blood pressure, and catching early signs of proteinuria or hypertension, all of which reflect a deeper truth that having one kidney doesn't make you weaker. It just makes your awareness more valuable, your health more precious, your relationship to your body more conscious, and perhaps most beautifully, the fact that a person can live with one kidney and give the other away reminds us that human life isn't only about what we possess, but what we can live without, what we can give without breaking, what we can lose and still remain whole. And that kind of resilience, that cellular generosity, that structural humility is something far greater than anatomy. It's a model for how to live prepared, but not afraid, adaptable, but not reckless, giving, but not diminished. Because sometimes the strongest systems are the ones built with intentional excess, not waste, but readiness. And the kidney stands as a quiet guardian of this principle, reminding you every day that your body is not a fragile machine, but a flexible, regenerative, sacrificial organism, capable of recalibrating even after significant loss. And in a world that often teaches you to fear losing what you think is essential, your kidneys whisper a different kind of wisdom. That redundancy isn't wasteful, that simplicity can be powerful, and that even when life cuts away a part of you, you are more than capable of carrying on, not in half measure, but fully, strongly, and without pause. Blood vessels can circle the earth. You might not feel it, but right now, whether you are sitting still or walking, whether you are joyful or tired or lost in thought, there's a vast, living river moving inside you, an invisible network of highways and alleyways, loops and spirals and microscopic tunnels that reach into every inch of your being, feeding your cells, varying signals, sweeping away waste, warming your skin, cooling your organs, and wrapping you in a kind of pulsing biological web that keeps you alive second by second. And if someone were to take all those vessels inside you, every artery, vein, capillary, and stretch them out in a single line, they would circle the earth, not once, but 2 to 2, and a fair half-time spanning over 100,000 kilometers in length, an almost incomprehensible measurement packed into the human frame, curled within layers of tissue, coiled within organs, nestled against bones, and threaded between muscle fibers, like a secret map written in red and blue ink. Proof that your body, despite its size, contains multitudes, not metaphorically, but physically. And this network, known as your vascular system, is far more than a set of pipes. It is a dynamic, self-regulating living system, built with astonishing complexity and precision, one that begins developing just 3 weeks after conception, as your embryonic cells form primitive tubes that eventually grow into the intricate branching structures that sustain your life. And from the moment your heart begins to beat, this system becomes the architecture of your survival, expanding and adapting as you grow, repairing itself silently when it's injured, sensing when to dilate or constrict in response to temperature, pressure, posture, or stress, and performing millions of tiny adjustments every day to keep your body in balance. And it's not just the size of the system that's mind-blowing, it's how specific it is. Each organ has its own vascular fingerprint, with blood vessels tuned for their environment. The kidneys receiving more blood per gram than any other organ. The brain protected by the selectively permeable blood-brain barrier. The skin pulsing with microcirculation to manage heat, and the heart itself fed by its own coronary arteries to sustain the very pump that moves everything else. Your largest blood vessel, the aorta, is nearly the width of a garden hose, carrying oxygenated blood, with each heartbeat at speed s of around 1 meter per second, while your smallest capillaries are 10 times narrower than a human hair, so thin that red blood cells must pass through in single file, sometimes even folding themselves to fit. And in between lies a vast hierarchy of vessels, arterioles, venules, branches, sub-branches, each designed with fluid dynamics in mind, using geometry to manage pressure, minimize turbulence, and ensure that nutrients and oxygen reach even the most remote cells in your fingertips and toes. And the fact that you have this earth-spanning vascular system packed inside you is not just a statistic. It's a story of scale, of biological origami, of how nature folds and folds again to compress vastness into function. And even more incredible is how responsive this system is to your choices. Exercise strengthens vessels, reduces arterial stiffness, and builds collateral circulation stress. On the other hand, can cause constriction, increase blood pressure, and over time contribute to the formation of plaques or microbes. Hydration keeps your blood volume healthy, sleep regulates vascular tone, and even emotions, fear, excitement, love, can send signals through your autonomic nervous system that change your circulation in real time. Making this system not just mechanical, but expressive. It mirrors your state of being, and when you touch someone's hand and feel warmth, that's blood vessels dilating to share heat. When you blush in embarrassment, it's your vessels flooding the skin of your face with blood. When your fingers go pale in cold, it's the vessels constricting to conserve warmth for your vital organs. And this responsiveness reveals a profound intimacy between your internal world and your external reality. A kind of biofeedback loop that makes you more than just flesh and code. It makes you interpretable, sensitive, porous to the world around you. But perhaps most astonishing of all is how the vascular system becomes a bridge between the brain and body, how baroreceptors in your arteries monitor blood pressure and communicate with your brainstem to adjust your heartbeat, how nitric oxide produced by the endothelium, the lining of your vessels, can instantly change vascular tone, how injury anywhere in the body initiates a cascade of responses, summoning platelets, cytokines, and immune cells via the bloodstream to initiate repair, and how even a thought, a memory, an idea can trigger vasodilation or constriction, proving that your blood vessels don't just carry your biology, they carry your experience. And yet, despite its importance, your vascular system is rarely celebrated. Until something goes wrong, until a clot lodges in a lung, or an aneurysm silently grows, or hypertension wears down the arterial walls. And that's when we remember how fragile this vast invisible highway really is, how critical it is to maintain its integrity, not just with medicine, but with daily choices, with movement, with rest, with nutrition, with peace, and still, even under strain, the vascular system amazes with its ability to reroute, to bypass, to form new branches after a blockage, to build resilience under pressure. And that, too, is a metaphor, that life flows through us in branching paths, that even when one route is blocked, new ones can grow if the conditions allow. That circulation, like emotion, like thought, like love, requires movement, pressure, release, and return. And so when you sit quietly and feel your pulse, or press your fingers to your wrist, or watch someone's chest rise and fall, remember that beneath that stillness is 100,000 kilometers of motion, of liquid life spiraling through a system shaped like the earth itself, winding, looping, adapting, pulsing. A system that began before you had thoughts, and that will carry on until your last, without recognition, without rest, and yet fully, faithfully, continuously, reminding you with every beat that you are a planet unto yourself, wrapped not in oceans or winds, but in rivers of red, and they have never stopped moving. Heartbeats sync with music. You might not notice it consciously, but there's a quiet phenomenon happening inside you whenever you listen to music. Something subtle, measurable, and deeply human. Your heart, the organ that never rests, that pulses on even while you sleep, begins to adjust its rhythm ever so slightly to the tempo of the sound washing over you. And while it may sound poetic, it's biologically real. Your heartbeat can, and often does, synchronize with the beat of music, not as a metaphor, but as a physiological response shaped by the hidden wiring between your senses, your brain, and your autonomic nervous system. And this mysterious synchronization, known as entrainment, reveals a profound truth about your body, that you are not just a listener of rhythm, but a participant in it, a vessel that responds, resonates, and even aligns with the patterns it perceives. And the deeper you go into this reality, the more remarkable it becomes, because your heart rate is not fixed. It fluctuates constantly based on context, mood, breath, and stimulus, and music, in particular, has an uncanny ability to reach in and recalibrate your internal tempo, whether by calming you with slow, ambient tones or exciting you with fast, percussive rhythms. And this entrainment effect has been observed across cultures, age groups, and even species. But it's especially noticeable when people listen to music with strong regular beats, like classical adagios, lullabies, techno tracks, or marching bands. In these moments, your cardiovascular system begins to mirror the external rhythm. Your blood pressure may stabilize, your breathing rate starts to match the pH raising of the melody, and your heart rate gradually shifts toward the pace of what you're hearing, as if your body is joining the performance without needing permission. And this isn't a vague emotional impression. It's been measured in real time using ECG and pulse, tracking slow tempo music, say 60–80 beats per minute, consistently reduces heart rate, decreases sympathetic nervous activity, and promotes parasympathetic relaxation, while faster music increases alertness, energizes muscles, and synchronizes motor activity. Even athletes use it to time movements, and surgeons sometimes choose playlists based on the procedure they're performing, optimizing precision by tapping into this same regulatory effect. But the question remains, why does this happen? Why would evolution allow your body to become vulnerable to music? Something intangible, abstract, and not directly tied to survival. And the answer lies partly in your brainstem, where auditory input converges with autonomic regulation, and partly in your limbic system, where emotion and memory blend. But perhaps most intriguingly, in your brain's default mode network, the system that governs introspection, empathy, and narrative processing. Because when you listen to music, especially music that moves you emotionally, your brain lights up across regions that process time, prediction, motor intention, and memory. And these networks don't work in isolation. They send feedback loops to your heart via the vagus nerve, adjusting heart rate variability based on your perceived emotional state. So a melancholy cello passage or a rising chorus isn't just affecting your ears, it's engaging your whole organism, shifting your physiology into sync with the sounds outside of you. And what's more, this synchronization can also happen socially, or even concerts, when multiple people begin to breathe and beat in unison. A kind of shared biological rhythm emerges, leading to increased feelings of connection, empathy, and bonding. And this has been tested in studies where participants singing or clapping together showed synchronized heart rates and galvanic skin responses, suggesting that music doesn't just modulate individuals, it harmonizes groups. And this matters because in a fragmented world where loneliness and disconnection are growing public health issues, music may be one of the last remaining rituals that unites hearts both metaphorically and literally. And there's more. Therapeutic applications are now being developed from this understanding: music therapy for heart disease, stroke rehabilitation, anxiety, PTSD, even neonatal care where premature infants show stabilized breathing and improved oxygenation. When exposed to carefully selected lullabies, their tiny hearts slowing in rhythm, with the melodies played through soft speakers in incubators, suggesting that rhythm may be among the first languages we ever understand, a communication deeper than words. And perhaps that's the key insight, that your heartbeat, though automatic, is not untouchable. It listens, it responds, it's malleable, and music, as ancient as breath, as universal as pain, as diverse as the cultures that birthed it, has always been one of the few forces capable of entering that sacred space between your consciousness and your biology, shaping how you feel, how you rest, how you connect, and how you heal. And maybe that's why we cry when violins swell, or feel courage when the drums rise or sink into peace, when the piano fades, because something inside us, cellular, electrical, emotional, is echoing back the message, saying, yes, I hear this too. I recognize this tempo. I want to move in harmony with it. And the next time you put on a song, even casually, even in the background, remember that it is not merely decoration for your mind. It's choreography for your body. It's dialogue with your organs. It's a moment when your invisible systems become musical instruments, tuned not to logic, but to vibration and timing and emotion. And in that moment, your heart, that soft, ceaseless drum tucked behind your sternum, listens and joins the rhythm, not just to keep you alive, but to remind you that life itself has a beat, and you are capable of feeling it. You're taller in the morning. You might never have realized it, but when you open your eyes in the morning and slowly rise from sleep, you are physically taller than you will be by the end of the day. Not metaphorically, not perceptually, but literally. Your spine, that central pillar of bone and cartilage that holds you upright, has subtly elongated while you slept. And this increase, often between 1 and 2 centimeters, is not some trick of posture or illusion of lighting, but a measurable biological phenomenon, a quiet consequence of the way gravity interacts with your body and how your spine decompresses during rest. A reminder that even your height, something most people assume is fixed, is in fact dynamic, shifting not just over decades or years, but moment by moment, depending on the pressure placed on your vertebrae. And when you first stand up, you're at your daily peak, taller than you will be after hours of walking, sitting, standing, bending, moving, and living under the weight of the day, because every action that involves gravity slowly compresses the intervertebral discs that sit like cushy ons between the bones of your spine, and although they are only a few millimeters thick each, their collective height loss adds up, squeezed by the weight of your head and upper body, fluid pushed out like water from a sponge, gradually reducing your stature without you noticing. And yet, this compression is not damage. It's part of a cycle, a rhythm, an oscillation between collapse and recovery. Because when you lie down again at night and gravity no longer pulls vertically on your frame, those same discs reabsorb fluid from surrounding tissues, swell gently, and restore your height as you sleep, which means that your body is not just enduring time, it is participating in it, moving in out of phases like tides, expanding and contracting in response to invisible forces. A slow, silent choreography you never rehearsed, but perform every day without fail. And this simple fact, that you are taller in the morning, opens up an astonishing world of insight into the mechanics and adaptability of the human body, because your spine is not a static rod, but a living, flexible structure made of 33 vertebrae stacked with remarkable engineering precision, with cartilage discs that act as shock absorbers, buffers, and micropumps all at once, capable of absorbing impact, transmitting force, and enabling motion while protecting the delicate spinal cord that runs through its hollow core. And these discs are composed of an outer ring of fibrous tissue called the annulus fibrosus and a jelly-like core known as the nucleus pulposus, which allows each disc to act like a suspension system. But unlike synthetic systems, Yours doesn't use springs or hydraulics. It uses fluid dynamics, osmotic pressure, and biochemical signaling to adapt to how you move and rest. And it's not just the spine that changes overnight. Your joints, especially in the knees and ankles, also subtly shift with pressure and rest. And understanding this daily fluctuation doesn't just help explain why your pants fit differently in the morning or why astronauts lose disc height in microgravity. It also hints at the deep interconnection between motion, hydration, and cellular health. Because your discs don't have blood vessels like most tissues. Instead, they rely on diffusion, meaning they absorb nutrients and fluid through pressure changes. When you move, you compress and release them, driving metabolic exchange. And when you sleep, you allow restoration to occur, making every step you take and every hour you lie down a contributor to spinal health. And yet, most people ignore this completely, treating their backs as static frames rather than living systems in motion, until pain arrives and reminds them that even structures meant to endure still require care. And what's even more fascinating is how this principle of fluctuating stature plays out over the course of a lifetime. As children, the discs are more hydrated, giving a bouncier spine and more variation between morning and night height, while aging leads to disc desiccation, reduced fluid absorbed, iron, and a gradual decrease in height overall. But even in adulthood, your body is constantly adjusting, compensating, managing pressure, and the knowledge that you shrink during the day and regrow overnight serves as both a metaphor and a mechanism, a literal cycle of wear and renewal playing out in your bones. And it also opens doors to subtle questions. How much of who you are is fixed, and how much is negotiable? How many other traits, states, or limits that feel permanent are actually in flux, shifting silently with context, posture, and attention? If something as seemingly immutable as your height can ebb and flow with gravity, then maybe more of you is elastic than you've ever been told. And perhaps that's the hidden beauty behind this quiet fact that you rise each day not just mentally or emotionally, but physically, that your very body participates in a form of rebirth that requires no ritual, no belief, no ceremony. Just sleep, rest, and time away from pressure. And this reminds you that restoration isn't abstract. It's anatomical, measurable, rooted in physics and fluid. And while we often think of growth as something that happens once during childhood and then stops, your spine teaches otherwise. That growth is cyclical, that compression is not the end but a phase, and that even under the persistent force of gravity, you still find ways to rise again. And maybe that's why waking up can feel like a beginning, even when nothing has changed. Because in those quiet morning hours, you are technically a different version of yourself. Slightly taller, subtly reset, briefly free from the weight of the world. And this small scientific truth carries an unexpected grace, that you are never exactly who you were yesterday, and that every night you lie down, you prepare to reclaim a fraction of yourself, that the day has worn away, not just metaphorically, but physically, structurally, atom by atom, breath by breath, cell by cell. Your body has a second wind. You felt it before, even if you didn't know its name. That strange resurgence of energy, just when you thought you had nothing left. That moment during a long run, or a draining task, or a late night project when exhaustion begins to blur the edges of your focus. Your legs feel heavy, your breath grows shallow, and everything in you whispers to stop, to quit, to lie down. And yet, somewhere beyond that breaking point, often when you are convinced you are past your limit, a quiet shift begins, and the fog of fatigue lifts. Your breathing evens out, your thoughts clarify, and your body, almost impossibly, seems to wake up again, giving you a second chance, a second strength, a second wind. And while it may feel like a psychological illusion or a poetic myth, this phenomenon is deeply rooted in the mechanics of your physiology, a real and measurable shift in the way your body manages fuel, breath, chemistry, and willpower under stress, especially during sustained effort where a complex ballet of metabolic transitions, neurological adaptations, and hormonal signaling take place in the background without your conscious permission. Because what you experience as a second wind is actually your body shifting gears, metabolically, energetically, and emotionally, from an anaerobic state, where you burn limited short-term fuel like glucose without oxygen, to a more sustainable aerobic state, where your cells begin to rely more heavily on oxygen-based energy production and tap into longer-term fuel reserves like fat, which takes longer to access, but burns cleaner and steadier. And this transition isn't instant or automatic. It requires a period of discomfort, of energy debt, of internal stress signals reaching critical thresholds. And only then does your system recalibrate, redirect blood flow, increase oxygen uptake, open up your pulmonary capillaries, release endorphins, and engage the brain's limbic reward pathways, transforming the experience from painful to almost euphoric. And this isn't just for runners or athletes. It happens during mental work, emotional endurance, grief, learning, parenting, caregiving, healing, where the initial push into effort feels overwhelming, unsustainable, even impossible, until suddenly you find rhythm, clarity, and momentum. Not because the task changed, but because you did, because your internal systems reorganized under pressure and decided not just to survive, but to adapt. And what's even more fascinating is that this isn't one singular phenomenon, but a recurring pattern observable in multiple domains. Your muscles experience it, yes, but so does your brain, your immune system, your lungs, and even your psychological resilience. And scientists are beginning to understand that what we call second wind is actually a family of internal thresholds, metabolic tipping points, neurological recalibrations, and emotional inflection zones that must be crossed before stability is found, much like turbulence, before leveling out during a flight, or the chaos of ignition before the calm hum of cruise speed. And there's something profoundly human about this pattern, that you often meet your true capacity, not at the start of effort, but after discomfort, after resistance, after almost giving up. And this also means your limits are rarely where you think they are, because your brain, in an attempt to protect you, sends out early warning signs long before actual depletion, a biological trick designed to conserve energy and avoid risk, but not always accurate. And so when you hit the wall, whether it's mile 3 or minute 40 or day 10, what you're feeling might not be the end of your energy, but the end of your first phase. And if you push a little farther, gently, patiently, you may discover a deeper reservoir, one that isn't powered by adrenaline or panic, but by a more balanced, sustained engine of efficiency and adaptation. And this realization carries enormous implications, that persistence isn't just about toughness, but about knowing that your body and mind are designed to become better under pressure, if given time and patience, that the breakthrough often waits on the other side of the breakdown. And it also teaches compassion, because everyone you know at some point is somewhere before their second wind, in the heavy phase, in the pain, in the breathlessness. And if you understand this, you stop judging people by their struggle and start admiring them for staying in the process long enough to transform. How burnout can dim your inner light, how despair can feel like suffocation. And yet, given rest, rhythm, and room, the soul too finds its second wind, reconnects with purpose, rediscovers curiosity, rekindles joy. And it's not a surge or a miracle, but a process, one that mirrors what's happening in your body during exercise, where neurotransmitters like dopamine, serotonin, and endorphins begin to flow again, where cortisol settles, where inflammation quiets and function returns. And if you begin to trust this, not just in the gym or at work, but in your life, you realize that recovery is not an accident, but an ability, a sequence of events waiting to unfold, if only you can stay with yourself long enough. And maybe that's the hidden gift in this biological fact, that even your muscles, your lungs, your brain, your heart are built with this wisdom, That the first wave is not the whole story, that exhaustion is not failure, that behind every difficult effort is a system preparing to shift, to rewire, to unlock strength that wasn't accessible at the beginning, but becomes available through endurance, through persistence, through quiet refusal to quit. And so the next time you feel yourself falter, whether on a trail, at a desk, in a hospital room, or in the long grey corridor of emotional fatigue, remember this: your body has done this before, millions of times across evolution, across your own life, in moments large and small, and it knows how to find its second wind. Not because it's heroic, but because it's human, because adaptation is your birthright. And the fire that flickers does not mean the fire has gone out, only that it's about to shift from spark to flame, from survival to resilience, from just making it through to moving with strength, rhythm, and renewed breath again. You breathe more through one nostril at a time. You might think of breathing as something symmetrical, something even and balanced, a soft dual current flowing through both nostrils in perfect harmony. But the truth, quiet, subtle, and almost entirely unnoticed, is that you actually breathe more through one nostril at a time, and which one it is changes in a slow rhythm throughout the day, in a cycle that lasts roughly every 90 minutes to a few hours, switching sides in an alternating pattern known as the nasal cycle. A physiological rhythm that was discovered in ancient yogic texts thousands of years ago, but only scientifically confirmed in the last century, and once you notice it, you can't unfeel it. The faint dominance of air on the left or right, the slight openness of one side, the gentle resistance of the other, as if your body is subtly tuning your awareness, shifting your focus, even regulating your brain hemispheres, without asking for your input. Because this alternation isn't random, and it isn't meaningless. It's deeply tied to your nervous system, your cognitive performance, your emotional regulation, and even your body temperature, digestion, and sleep cycles. And though you might assume that airflow would always favor both nostrils equally for efficiency, nature seems to prefer asymmetry, even in something as essential and rhythmic as breath. And here's how it works. Inside your nose are erectile tissues. Yes, similar to those found elsewhere in the body, that can swell and shrink with blood flow, controlled by the autonomic nervous system, particularly the sympathetic and parasympathetic branches, which modulate which side opens and which side gently closes at any given time. And when one nostril is more open, air flows more freely through it, while the other is partially congested, not enough to block, but enough to reduce airflow. And this difference in airflow subtly influences the temperature, humidity, and speed of the air entering your lungs, affecting how your body filters, warms, and humidifies oxygen. And even more intriguingly, these differences affect the brain. Studies suggest that right nostril breathing is linked to increased activity in the left hemisphere, associated with logical thinking, focus, and alertness, while left nostril breathing increases activity in the right hemisphere, linked to creativity, emotional awareness, and calm, which means that your breath, something you usually take for granted, is not just fueling your body, but steering your mind, tuning your consciousness like a dial as your nostrils trade places in a gentle dance orchestrated below the surface. And yogic practices like pranayama have long utilized this knowledge, deliberately controlling breath through one nostril to influence mood and mental state, a technique that modern neuroscience is only beginning to understand. And yet, this cycle isn't just about mental state. It is about balance, efficiency, and sensory processing. Because the alternating airflow allows each side of your nose time to rest and recover, preventing over-drying, increasing olfactory sensitivity, and allowing mucus and cilia to function optimally. And while the exact function of the nasal cycle remains partly mysterious, it appears to be part of your body's broader circadian and ultradian rhythms, those internal clocks that govern sleep, hormone release, attention, digestion, and even emotional rhythms. And what is so striking about this is not just the biology, But the invisibility of it all, how something so consistent, so vital, so quietly powerful could exist for your entire life without you ever noticing, like a secret current beneath the surface of consciousness, shaping your experience in ways you never named. And once you know this, you begin to feel it in real time. When you're anxious, you might find yourself breathing more through the right nostril, revving your system when you are sleepy or emotionally heavy. The left nostril might be in dominance, inviting introspection and calm, and the body, it seems, is always balancing you. Even when your mind is lost in chaos, even when your thoughts don't cooperate, even when you've forgotten what stillness feels like, your nose keeps switching sides, quietly, gently, rhythmically, pulling you back into alignment without ever demanding your attention. And the deeper truth is this: breath is never just breath. It's information, rhythm, communication between body and brain, between emotion and physiology, between the external world and your inner state. And by alternating nostrils, your body is offering you something profound, a built-in system of restoration and focus, of balance and adaptation, of logic and intuition. As if within you lives a silent metronome, not just marking time, but adjusting the lens through which you experience the world. And maybe that's the most beautiful part of all, that something so ordinary could be so wise, that a mechanism you never noticed could be harmonizing your awareness all day long. And in a world that often feels overwhelming, out of sync, and overstimulated, this quiet switching of sides, unnoticed, uncommanded, is a whisper from your biology reminding you that balance is not a thing you chase, but a thing you already do, a rhythm you already live. And if you ever feel uncentered, ungrounded, lost in thought or fogged in emotion, try pausing for a moment, placing a finger gently beneath your nose, and simply noticing which side is more open, which nostril carries the wind of the moment. Which side are you living through right now? Because in that simple act of noticing, you bridge the unconscious with the conscious. You meet your body halfway, and you realize that the rhythm of life has always been inside you, switching sides, adjusting sails, guiding you silently toward equilibrium, one breath at a time. Muscles remember movements. If you've ever picked up a bicycle after years of not riding, placed your fingers on a piano after a decade of silence, or found your hands tying a knot before your mind could even recall the steps, then you've touched the edge of something strange and powerful, something science calls muscle memory, though that name barely captures the mystery of what's really happening beneath your skin. Because this isn't memory in your muscles at all, but rather a deeply ingrained pattern encoded through repetition in the neural circuits connecting your brain, spinal cord, and body in a way that bypasses conscious thought entirely, allowing you to perform complex movements with speed and precision, without needing to remember how you learned them in the first place, as if some invisible part of you has been practicing behind the scenes, rehearsing even in your absence. And the more you look into it, the more you realize that what we casually call muscle memory is actually a profound example of how your body becomes your mind, how action becomes identity, and how movement writes itself into the very architecture of who you are, not with words or logic, but with timing, rhythm, and silent coordination, across countless feedback loops, refined through trial and error, etched into motor neurons, and strengthened by a principle known as myelination, where the more you repeat a movement, the more insulated and efficient the neural pathways become, wrapping themselves in fatty layers like electrical wires to speed up signals and make the movement feel effortless, automatic, and natural, even if it once took months or years to master. And what is truly fascinating is that this memory can outlast even your ability to consciously describe the motion. It stays in the body long after it fades from verbal awareness, which is why dancers can move in sequences they can't always explain, why typists can type full paragraphs without thinking of individual letters, and why soldiers or athletes drilled in high-stress conditions can react with perfect timing even under extreme pressure. as if they've handed over the controls to a more primal, practiced version of themselves that knows exactly what to do without asking for permission or needing to think it through. And in this way, muscle memory becomes a kind of hidden intelligence, a form of unconscious expertise that rewires your relationship with time and space, because it allows you to act faster than thought, to move without deliberation, to embody knowledge in a way that feels intuitive and instinctive, but is actually the result of thousands of repetitions carved into your nervous system like grooves in a record, grooves that get deeper the more you use them and never quite disappear, even after long stretches of disuse, because once those neural circuits are built, they linger, waiting to be reawakened, which explains why former athletes regain form quickly after returning to training, or why playing a childhood video game can feel uncannily familiar, your fingers finding the buttons with ghost-like certainty, reminding you that even when your mind forgets, your body remembers. And this raises deeper questions about the boundary between learning and being, between knowing and doing, because muscle memory isn't just about physical tasks. It's about how experience shapes your behavior without requiring conscious thought, how repeated actions become embodied habits, and how those habits can define your sense of self, your competence, even your confidence. Because the more you internalize a skill, the more it becomes part of your identity. And this is why losing a physical ability through injury or aging can feel so disorienting, like losing a part of who you are, not because your muscles forget, but because the pathways that once carried those fluent signals are disrupted. And rebuilding them requires patience, repetition, and trust in the process that originally built them. A process that neuroscience now understands involves not only the motor cortex, but also the basal ganglia, cerebellum, and spinal circuits working in synchrony, adapting through feedback and gradually shifting control from the effortful conscious system to the efficient automatic one. Much like how learning to drive a car is at first overwhelming and slow, but eventually becomes so second nature that you can navigate home while having a conversation or listening to music, unaware of each individual movement, but executing them flawlessly. And the implications of this are vast, not just for athletes or musicians, but for anyone trying to build new habits. Because what we repeat physically, emotionally, or mentally becomes easier over time, not by magic, but by neural adaptation. And this applies to posture, breathing, handwriting, stress responses, even facial expressions and tone of voice, all of which can be conditioned into the body's memory until they operate beneath the surface, steering how we move through the world, and how the world responds in turn. And it's here we start to see muscle memory, not as a mechanical repetition, but as a form of embodied intelligence, where the body becomes a storehouse of patterns, preferences, and possibilities, where it doesn't just obey the brain, but teaches it, refines it, guides it, and sometimes overrides it. And this reverses the common view of the brain as the command center, placing the body as an equal partner in cognition, learning, and selfhood. An idea supported by research into procedural memory, sensoromotor integration, and embodied cognition, all of which reveal that cognition doesn't happen in the brain alone, but in the full loop of sensation, movement, and adaptation that unfolds through lived experience. Which is why no amount of theoretical knowledge can replace practice, and why mastery is not just about knowing what to do, but becoming someone who is the doing, someone whose mind is embedded in motion, whose intelligence is expressed through fluidity and grace. And this might be why some of our most powerful moments, dancing freely, playing an instrument, flowing through martial arts, feel like losing ourselves, not because we've become less, but because we've handed control to a deeper, more intuitive self that doesn't need to think. And in that moment, we're not separate from our actions. We are the action, fully present, fully expressed, and this offers a deeper reflection. If movement can be remembered without conscious thought, if the body can act in wisdom long after the mind forgets, then perhaps memory itself is broader than we've imagined, not just stored in neurons, but in movement, posture, reaction, and rhythm. And in this view, you aren't just a brain with a body. You are a living archive of every repetition you've ever done. Breath, tremor, and skill etched into your nervous system as silent knowledge waiting to be reawakened. Which means your potential is not limited to what you can think, but includes what you've practiced, even if imperfectly. And this makes each repetition, each effort, each clumsy try a vote toward the person you are becoming, one movement at a time. Bones are continuously replaced. You may think of your skeleton as something fixed and finished, as a rigid frame forged in childhood and slowly eroded with age. But the truth is far more dynamic and stranger than it first appears, because beneath your skin, deep within the quiet chambers of your bones, a silent construction crew works around the clock, breaking down and rebuilding you molecule by molecule, year after year, in a cycle so constant and invisible that you rarely pause to wonder if the bones inside you today are even the same ones you were born with. Because they're not entirely. And in fact, the skeleton you carry now is the result of countless microscopic demolitions and reconstructions, each one carefully orchestrated by a biological rhythm that doesn't just repair damage, but completely regenerates your frame over time, meaning that the very foundation of your physical self is always in motion, always being replaced, not in some metaphorical sense but literally with old bone tissue dissolved by specialized cells called osteoclasts, while new bone is laid down by their counterparts, osteoblasts, in a delicate dance of destruction and renewal that scientists call bone remodeling. And this process is not a background detail of human biology. It's central to how you grow, heal, adapt, and even remember movement, because bone isn't just structure, it's alive, a responsive tissue that senses strain, adjusts to pressure, and adapts to the forces you place on it every single day, constantly rewriting itself in response to your habits, your environment, and even your emotions. Because stress hormones can alter remodeling rates, while physical exercise can stimulate bone growth, and lack of use can accelerate breakdown, showing that your skeleton listens to your life and quietly adjusts to fit it. Not just in childhood or adolescence, but throughout your entire existence, a fact that challenges the very idea of identity and permanence in the body. Because if even your bones are temporary, if even your most solid parts are made to be unmade, when May is always in flux, always under renovation, always becoming something new without asking for your permission or announcing the transformation. And the deeper you explore this phenomenon, the more you begin to understand that bones are not just scaffolding for the muscles. They are active, living organs involved in a vast network of interactions, producing hormones, regulating minerals, and even contributing to immune function, with marrow that generates blood cells and microscopic structures that sense mechanical forces, all while constantly replacing themselves through a process so complex it mirrors the software updates of a living system, one designed not for permanence, but for flexibility and survival in a changing world. And perhaps the most astonishing part is that this system doesn't just respond to damage, it anticipates it, maintaining a balance between breakdown and build-up that allows for subtle reinforcement in the places where strain is greatest, meaning that a violinist's shoulder or a runner's shin bone will strengthen in unique patterns, customized by the life that bone supports, forming a kind of skeletal autobiography, etched not in ink, but in calcium and collagen. And this process isn't uniform or evenly paced. Children replace their entire skeletons roughly every 7 years, while in adults the cycle slows, but never stops, and continues until death, sometimes even beyond, as forensic science can now read bone remodeling patterns to determine age, health, and activity levels long after a person is gone, transforming our bones from passive structures into living timelines that tell the story of who we were, what we did, and how we lived. And this knowledge reshapes how we think about injury and recovery too, because healing a broken bone isn't just about setting it in place. It's about guiding the remodeling process, supporting the cellular engineers who are already at work tearing down the damaged parts, and replacing them with new matrix, new structure, built from minerals harvested from your diet and hormones signaled by your brain. Which means nutrition, sleep, and even mindset can influence how well you rebuild. And this insight opens up a vast new understanding of how intimately connected our physical habits and emotional states are to our internal architecture. With modern research now linking chronic stress to weakened bone density and weight-bearing activity to enhanced remodeling efficiency, painting a picture of the skeleton as a highly adaptive, environmentally sensitive organ, less a fossilized framework, and more a biological mirror that reflects the pressures of life, the rhythm of action, and the will to continue despite entropy. And from this perspective, the idea that bones are hard becomes a misconception, because what's hard is the mineralized tissue we observe in the moment. But what's real is the process, the never-ending tide of breakdown and renewal, of osteoclasts tunneling into bone like miners and osteoblasts following behind to fill the tunnels with fresh deposits, forming Haversian systems like rings in a tree, encoding age, wear, and adaptation into every layer. So that even if you never think about your skeleton, it is thinking about you, tracking your movement, responding to your weight, healing your fractures, and preparing for the next challenge before you know it's coming. A silent, tireless engineer maintaining the foundation of your life in a cycle, so seamless, you only notice it when it nails when fracture or disease interrupts the balance and forces you to reckon with just how alive your bones really are. And in doing so, you're confronted with an unsettling truth. Your sense of bodily permanence is an illusion, because what seems solid is actually transient. What feels stable is in constant flux, and the body you live in is not a finished product, but a work in progress, a dynamic organism built on the principle that to survive is to change, to adapt, to rebuild. And so perhaps the question is not whether your bones are still the same as they once were, but what version of you they are building now, silently, cell by cell, in anticipation of the future you haven't yet lived. You sweat even when you don't feel it. You might think you only sweat when you are hot, anxious, or exercising. But your body operates on a much more subtle and continuous rhythm than you realize. Because right now, even as you sit still, even as your skin feels dry and cool to the touch, your sweat glands are already active, already working, already releasing invisible layers of moisture you never notice. And this quiet, constant secretion is not a flaw in perception, but a feature of survival, part of a highly evolved thermoregulatory system that doesn't wait for you to feel warm to take action, but stays ahead of the curve, anticipating rises in core temperature and gently balancing your internal state before discomfort even begins, like a silent guardian regulating your engine so efficiently that you barely know it's running. And what makes this even more fascinating is that the majority of your sweat, especially in a neutral or resting state, is not meant to cool you down through dripping or visible moisture, but to maintain a specific level of skin hydration and temperature through a process called insensible perspiration, which accounts for nearly half a liter of water loss every day, unnoticed and uninterrupted, slowly diffusing through your skin's surface into the air without ever beading up or being wiped away, meaning that much of your sweat never feels like sweat at all. And yet it's essential for homeostasis, for maintaining the delicate equilibrium between your body and the environment. And this becomes even more intriguing when you consider that your body houses two distinct types of sweat glands, eccrine and apocrine, each with their own roles, triggers, and chemical compositions. With eccrine glands numbering in the millions, scattered across your entire body, but especially concentrated on your palms, soles, forehead, and chest, responsible for this quiet, constant sweating that helps regulate your internal thermostat by releasing mostly water and salts, while apocrine glands, located primarily in areas like the armpits and groin, produce a thicker, oilier secretion activated more by emotional stimuli than temperature. And although apocrine sweat is minimal in volume compared to eccrine output, it contains proteins and lipids that bacteria on your skin feast upon. producing the odors we often associate with nervousness or stress, which reveals that not all sweat is created equal. Some is for cooling, some is for signaling, some is for silently protecting your skin from cracking, overheating, or infection. And the fact that your body maintains this system around the clock without your conscious awareness speaks volumes about how deeply your biology is tuned to environmental threats you rarely consider, like a room slightly too warm, a rising body temperature during REM sleep, or the minor fluctuations of heat during digestion, each of which can trigger low-level sweat responses that begin before you register the change. And in this light, sweat is not just a bodily fluid. It's a form of communication between your nervous system and your environment, a language of water and salt, written invisibly on your skin, adapting in real time to preserve equilibrium. And while most people associate sweating with discomfort, odor, or embarrassment, the truth is that without it, your body would quickly spiral into dysfunction, with even a slight failure in sweating capacity, such as in heat stroke or certain neuropathies, posing a potentially life-threatening risk, showing that this quiet process is not only constant but vital, and its efficiency is astounding, allowing your body to dissipate up to 600 watts of heat per hour through evaporation under extreme exertion, essentially turning your skin into a living air conditioner. And this mechanism is so effective that no synthetic cooling system can match its adaptability, which is why athletes, astronauts, and extreme environment workers still rely on it, despite all advances in technology. And yet most of us never learn how it works, or how complex it is, or that even the nervous anticipation before public speaking or a difficult conversation can trigger a measurable increase in sweat, not from heat, but from emotion, through sympathetic activation of specific sweat glands, creating a feedback loop between your thoughts, your nerves, and your skin, meaning that sweat doesn't just respond to your body, it responds to your mind. And in this way, it becomes more than physiology. It becomes a silent mirror of your inner world, revealing tension before you name it, anxiety before you speak it, fear before you admit it. And all the while, it performs crucial, behind the scenes tasks like maintaining the pH of your skin, keeping pathogens at bay, and even subtly modulating touch sensitivity by influencing skin hydration levels, because dry skin transmits sensations differently than moist skin, and so your sweat alters the way you feel the world, literally, in every moment, creating a layer of sensory modulation that adjusts your contact with the external world even when you don't notice. And this leads to profound questions about the boundary between the conscious and the unconscious body. Because if your skin is constantly adjusting, your sweat glands constantly responding, and your body constantly adapting to conditions, you don't even feel then how much of your daily survival depends on mechanisms you never think about, and how much of your experience of comfort, presence, and emotional state is subtly influenced by the whisper of moisture passing silently through your skin, which makes the idea of being in control seem less like a matter of willpower and more like a matter of collaboration between your conscious self and the autonomic processes that keep you alive. And in that light, sweat transforms from a source of social anxiety into a quiet miracle, an ancient adaptation refined by millions of years of evolution to handle fire, ice, stress, and sleep, a process so intricately tuned that it adjusts sweat rates not just by temperature, but by body region, with your back and chest sweating differently than your forehead or forearms, depending on metabolic heat zones, and even varies with circadian rhythms, changing its pattern based on time of day and hormonal cycles, subtly shifting the landscape of your body to match internal and external needs before you notice, before you act, before you even feel. And once you grasp this, once you realize that your body is sweating right now without telling you, that it's preventing overheating, adjusting sensation, protecting your skin, responding to your feelings, and preserving your internal temperature with each invisible molecule it releases, you begin to see that the body is never idle, never still, and that the stories it tells are not always in words or thoughts, but in fluids, rhythms, and invisible acts of maintenance that keep you alive without asking for your attention. And from that understanding, you may find a new respect for the subtle systems of the self. The quiet ones, the ones you don't see, the ones you don't feel but that never stop working on your behalf. Every organ has a circadian clock. You may believe that time lives only in your watch or calendar, that it's something external, a human invention meant to track the sun or measure progress. But your body tells a different story, one that pulses not by mechanical seconds, but by molecular rhythm, because within you, in every cell and every organ, from your liver to your lungs, your pancreas to your skin, lives a hidden clockwork, an intricate network of biological timers that don't just tick with life, but orchestrate it. And this internal timing system, known as the circadian rhythm, is not merely a background process controlling your sleep and wake cycles, but a deeply embedded timekeeping structure that governs nearly every physiological function in your body, with each organ following its own unique daily schedule, coordinated yet independent. Like instruments in a massive biological orchestra playing the score of your survival. In 24 symphonies of chemical anticipation and genetic choreography. And what's extraordinary is that these peripheral clocks, found in tissues throughout your body, are not solely dependent on your brain's master clock in the suprachiasmatic nucleus of the hypothalamus, but can shift based on your habits, your environment, and even your diet, meaning that your liver knows when you usually eat and prepares enzymes in advance. Your kidneys adjust salt regulation according to the time of day. Your intestines prime themselves for digestion hours before your first meal, and your heart tunes its own readiness for activity, depending on when it expects you to be awake or asleep, showing that your organs are not passive structures responding to need, but predictive systems actively shaping your readiness to function based on when they believe the demand will arrive. And this means your body is not merely reactive, it is temporally intelligent, aligning its performance with the rhythms of the world it assumes you live in. And when that alignment breaks, when your schedule shifts or your routines collapse, like during jet lag, night shifts, or insomnia, the dissonance between your internal clocks and the external world can cascade into metabolic disruption, hormonal imbalance, immune suppression, and even long-term disease. Not because your body is malfunctioning, but because its carefully tuned timekeepers have lost synchronization, like a symphony out of step, each section playing its part at the wrong moment. And this temporal architecture extends to the molecular level, where thousands of genes in every organ turn on and off, based on time of day, controlled by transcription. Translation feedback loops involving core clock genes like clock, BL1, PEP, and cry, genes that form the foundation of biological timekeeping, and whose expression patterns shape the rise and fall of hormones like cortisol and melatonin, regulate temperature, blood sugar, immune cell trafficking, and even DNA repair, all of which are timed for maximum efficiency and protection. So when you are key at dawn, it's not simply because the sun rose, but because your body was already preparing for that moment hours earlier, raising your core temperature, increasing your blood pressure, suppressing melatonin, and activating wakefulness, promoting circuits in the brain in anticipation of light, while your muscles begin adjusting calcium dynamics to enhance readiness for motion, and your digestive system starts ramping up acid production and insulin sensitivity in expectation of breakfast, creating a seamless transition from sleep to wakefulness that feels natural not because it is passive, but because it's orchestrated. And this orchestration is not fixed. It can adapt, but only up to a point, because while your body's clocks are flexible, they resist abrupt changes. And this resistance is why circadian misalignment, like eating late at night, staring at bright screens before bed, or staying awake during the biological night, can throw your systems into chaos, increasing inflammation, disrupting glucose metabolism, altering mood, and even impairing cognitive function, as each organ begins to fall out of sync with the others, performing its tasks too early or too late. creating metabolic jet lag within your own body. And perhaps the most surprising aspect of this system is that your behaviors don't just respond to your clocks, they reset them, meaning that when you eat, when you exercise, when you expose yourself to light, all serve as Zeitgebers, or time givers. External cues that recalibrate your internal clocks, with the strongest cue being light, especially blue light, which directly influences the master clock in your brain and cascades into the timing of every other organ. And this feedback loop between environment and biology suggests a profound interdependence, one in which your routines aren't merely habits, but instructions, telling your cells when to work, when to rest, when to heal, when to divide, and when to wait. And this dynamic opens a new frontier in medicine known as chronobiology, where treatments are timed according to biological rhythms to increase their effectiveness and reduce side effects. Because the same drug can have dramatically different outcomes depending on when it's taken, and surgeries performed at different times of day show varying recovery profiles, not due to surgeon skill or technique, but due to the patient's physiological state, which itself is shaped by the internal clock's readiness for stress, inflammation, and healing. Meaning that healing isn't just about what you do, it's about when you do it, and performance isn't just about effort, it's about timing, and well-being is not only a question of balance, but of rhythm, of aligning your behavior with the biological tides that rise and fall within you each day. And if we extend this understanding further, it leads to a profound rethinking of human health, not as a static state, but as a harmony of internal rhythms, constantly adjusting to both inner need and outer signal. And if we respect these rhythms, if we live in tune with them, we thrive. But if we ignore them, we may pay the price not immediately, but slowly, through subtle imbalances that accumulate into fatigue, weight gain, anxiety, cardiovascular risk, and even cancer, all of which have been linked in studies to chronic circadian disruption. And so the real question becomes, how well are you listening to your body's clocks? Do you feed them when they're expecting fuel? Rest when they begin their nightly repair? Give them light at dawn instead of midnight, because every choice you make is also a signal. A timestamp your body reads and responds to, reinforcing or resisting its natural rhythm. And the beauty of this system is that it's always waiting to reset, always ready to return to alignment if given the chance. Because your body doesn't seek perfection, only rhythm, only a return to the beat of a drum you can't hear. But that plays inside you nonetheless, guiding every breath, every heartbeat, every function of every organ that doesn't just exist in time, but keeps time. Hair remembers hormonal states. You might look in the mirror and see your hair as something decorative, dead, or forgettable, an accessory that changes with fashion, age, or preference. But what lies atop your head isn't just a passive thread of protein, it's a molecular archive, a silent historian that remembers far more about you than you ever intended it to. Because every centimeter of hair is like a fossilized journal entry, quietly encoding the hormonal states of your body during the time it grew. And what this means is that your hair doesn't just sit there, it testifies, storing biochemical footprints of your internal life, capturing your stress, your health, your endocrine patterns, and your invisible rhythms in layers, strand by strand, month by month, like tree rings, that don't measure weather, but your inner storms, revealing things even you might have forgotten or never consciously noticed. And this idea that hair remembers isn't poetic metaphor. It's a literal truth supported by decades of research, as scientists have discovered that hormones like cortisol, testosterone, estrogen, and others are incorporated into the keratin structure of hair as it grows, embedding traceable timelines into your strands that can be read and interpreted weeks, months, or even years later, long after the emotional or biological events themselves have passed. Meaning your hair holds a unique kind of biological memory, one that blood, saliva, or urine cannot match in temporal resolution. Because while those fluids reflect your current state, hair preserves your history. offering a slow, growing, durable archive of what your body has been through, layer by biochemical layer. And this concept changes everything we thought we knew about privacy, health, and the narrative of our physical existence. Because it means that a single strand of your hair can reveal how stressed you were in December, how your hormones fluctuated during exam season, whether you were pregnant or on medication, and even how your body responded to traumatic events, all with a clarity that sees memory, bias, or denial. And while this has obvious implications for forensic science and medicine, it also introduces deeper philosophical questions. If your hair can remember your emotions, your physiology, your struggles, does it, in some way, remember you not as you are now, but as you once were, captured in a protein helix that outlives the feeling, outlives the moment, and even, sometimes, outlives the body itself, surviving in artifacts like hair locks, preserved in culture, grief, or curiosity, and containing more truth than the stories we tell about ourselves. And from this lens, you begin to realize that hair is not merely an extension of appearance. It's an extension of experience, a time capsule of biological truth wrapped in keratin and silence. And the way it stores hormones is uniquely revealing. Because hormones are not static substances. They are signals, messengers of change and adaptation. And their presence in your hair shows not just what was happening chemically, but what your body was trying to do in response to life. Increasing cortisol to deal with pressure, shifting estrogen to prepare for reproduction, adjusting testosterone in response to stress or energy demands. All of it recorded without your awareness, forming a biochemical diary that nobody writes by hand, but everyone grows without ever intending to. And when you understand this, you see that hair isn't passive, it's forensic. It's an investigative tool your own body crafts to keep record of what it goes through. And that has become incredibly valuable to scientists and doctors, who now use hair samples to detect chronic stress patterns, monitor hormonal therapies, study psychiatric disorders, evaluate long-term exposure to toxins, and even track prenatal hormone exposure to better understand developmental outcomes in children. Because the hormones embedded in maternal hair during pregnancy can provide clucks, ease about in utero conditions more accurately than any retrospective report, offering insight into how environmental stress or biological shifts affect fetal development. And these applications continue to grow as technology improves, allowing us to read these strands like we would genetic code, except instead of fixed DNA, we are reading lived experience, unfolding across the scalp in gradients of biochemical residue that tell us where you've been hormonally, metabolically, and even psychologically. And what's more unsettling and intriguing is that this memory isn't even limited to your head, because body hair, though shorter and coarser, holds similar data, meaning your arm, chest, or leg hair carries its own abbreviated records of what your system was enduring during its formation, turning your entire integumentary system into a mosaic of biochemical history, scattered across your skin, speaking in silence, always documenting, never forgetting. And this brings us to a deeper awareness. You are not just shaped by time, you are stamped by it, marked by each wave of hormones that surges through you, not just in how you feel or behave, but in the literal growth of your body, the curling filaments that grow unnoticed and fall without drama, taking with them chapters of your internal life that only now are we learning how to read. And that ability to read them forces a re-evaluation of what it means to know yourself. Because memory, it seems, is not only in your brain, it's in your biology, inscribed into the structures your body weaves from protein and trace minerals. And while you may not remember what it felt like to live through a stressful winter or a joyful summer, your hair does. And it does not embellish, does not misremember, does not soften the past. It simply reflects it, atom by atom. And so your physical self becomes not just a reflection of your choices, but a record of them. And the longer you live, the more of this record you shed. Not just metaphorically, but literally, as each hair, that falls contains within it a molecular echo of your inner state, your hidden self, your endocrine signature. And as science begins to unlock these patterns, we face a future in which a strand of hair could diagnose depression, anticipate illness, monitor recovery, or expose chronic trauma in ways that conversations and surveys never could. And while this may seem invasive or eerie, it's also profoundly empowering, because it gives your body a voice that transcends shame or silence, a voice that can be studied, supported, and understood on its own biochemical terms, offering healing not just through words, but through data, through listening to the tissues that have been talking all along, if only we had the tools to hear them. And in that sense, the next time you see a hairbrush, a strand on your pillow, or a curl left behind in the drain, you might realize you're not just seeing something discarded, you're seeing something remembered, something that once grew in rhythm with your heartbeat, absorbed the chemical essence of your joys, your fears, your challenges, and now holds it in microscopic stillness, waiting, unknowingly, to tell your story. You're constantly fighting off microbes. You likely imagine battle as something loud, chaotic, external, something that happens in far-off fields, distant cities, or at the very least, during visible illness. But the most relentless war of your life isn't fought with weapons you can see or soldiers you can name. It takes place inside you, every second of every day, in complete silence, because even as you breathe, right now, even as your heart beats and your thoughts drift, your body is engaged in a constant, invisible war against an endless sea of microbial intruders. Bacteria, viruses, fungi, parasites, most of which you never feel, never notice, and never remember, not because they're harmless, but because your immune system is, quietly, perpetually neutralizing them before they can harm you, acting as a living shield of biochemical vigilance that scans, targets, disarms, and eliminates without your conscious awareness, like a sentient fog of sentries moving through your bloodstream, your skin, your saliva, your gut, your lungs, and even the crevices of your eyes. Each soldier trained not only to recognize familiar threats, but to anticipate new ones with algorithms written in evolution, forged by millennia of survival against microscopic enemies, so small they outnumber you by orders of magnitude, because in terms of sheer cell count, your body isn't even fully human. Microbial cells and viral particles within and upon you outnumber your own cells by roughly 10 to 1 at any given moment. And yet you do not fall apart, do not get sick constantly, do not collapse under infection, because your immune system has mastered the delicate balance between tolerance and aggression, allowing symbiotic microbes to live in harmony while launching complex attacks against those that cross the line into danger. And this balance is maintained through a breathtakingly intricate array of defenses, starting with the physical barriers. Your skin, a fortress of dead cells and antimicrobial peptides, your mucous membranes, coated in secretions that trap and neutralize, your stomach acid, so corrosive it can melt pathogens, and your tears, which contain lysozymes that disassemble bacterial walls before they can take hold, all of which form the front line of protection. But when those are breached, the deeper, more adaptive layers of your immune system activate, beginning with the innate response, where white blood cells like neutrophils and macrophages swarm the scene, engulfing invaders in chemical nets and digesting them like microscopic pac-men, sending out distress signals in the form of cytokines that summon reinforcements, raise body temperature to make conditions less hospitable for the pathogen, and initiate inflammation not as a sign of illness, but as a strategic maneuver to trap the enemy, isolate the damage, and accelerate healing. And while this innate response is fast and general, it's only the opening act, because if the threat persists, the adaptive immune system takes over, deploying T cells that can kill infected cells with surgical precision, and B cells that craft custom antibodies like microscopic locks designed to bind to microbial keys. and mark them for destruction. A process so specific and tailored that it constitutes true cellular memory. Because once your body has fought off a pathogen, it remembers it, not in your mind, but in your blood, storing the blueprint of the enemy in the archives of your lymph nodes and bone marrow, where memory cells can lie dormant for decades, waiting for a repeat encounter to unleash a faster, stronger, and more effective response, which is why you often don't get sick from the same infection twice, and why vaccines work, not by preventing exposure, but by preparing your internal army in advance, arming them with intel, so that when the real threat comes, it's already too late for it to win. And this biological intelligence is so remarkable that it can distinguish between billions of molecular shapes, deciphering friend from foe with accuracy that rivals the most advanced AI. And all of this happens continuously, whether you're awake or asleep, focused or distracted, in a hospital or on a mountaintop, because pathogens don't rest, don't retreat, and don't need permission to attack. They are ancient, opportunistic, and ruthless, mutating and adapting in real time, exploiting every weakness, hiding in plain sight, piggybacking on the food you eat, the air you breathe, the things you touch, the people you kiss, and yet somehow you are still here, still alive, still functional, because your immune system has been repelling wave after wave of these assaults without complaint, without credit, without rest. And this reveals a deeper truth. Survival is not the absence of threat, but the mastery of defense. And your ability to stay upright and healthy is not a baseline. It is an ongoing victory, renewed every day by trillions of cells working in coordination to keep your inner world clean, stable, and functional. Often at great cost, because sometimes the war takes a toll. Autoimmune disease, ACEs, chronic inflammation, allergies, all examples of what happens when the immune system misfires, fights the wrong target, or refuses to stand down. And this shows how delicate the balance is between safety and self-destruction, between immunity and overreaction, but on their wisdom, their restraint, their calibration to context. And as we learn more about this hidden world, we begin to see how everything affects it. Your sleep, your stress, your nutrition, your gut microbiome, even your emotions, all shape immune function, modulating its activity like a dimmer switch, rather than an on-off button, which means that when you laugh, your immune cells behave differently than when you're afraid. When you rest deeply, your body has time to repair and recalibrate. When you nourish yourself properly, you give your immune system the raw materials it needs to build, patrol, and remember. And in this sense, your daily habits are not trivial. They are strategic decisions in an invisible war you cannot afford to lose. And as research continues to uncover links between immune health and mental clarity, aging, chronic disease, and even social connection, it becomes clear that immunity is not an isolated system. It is your body's relational intelligence, your physiological memory, your silent protector, and understanding its complexity is not just about appreciating science. It's about recognizing that health is not a passive state you enjoy until it fails, but an active, ongoing negotiation between you and the microbial world, one that you are always participating in, whether you realize it or not. And from that awareness comes a new respect. Not just for your body, but for the unseen battles it wins on your behalf, moment by moment, with no fanfare, no parade, just the quiet continuation of life. Body heat can power micro-devices. It might not cross your mind that the warmth you feel in your chest, the subtle heat radiating from your fingertips, or the way your skin fogs a cold window, is more than just a byproduct of being alive. That your body's heat is not merely a passive signal of metabolic activity, but a potent, untapped energy source with the power to run machines, feed circuits, and even blur the line between biology and technology. Because what seems like waste, this quiet, constant release of thermal energy, is in fact a biological currency, one that engineers and scientists are now learning how to harness to power micro-devices that live on or even inside the human body. transforming you into something that isn't just alive, but electrically active. And this idea, once relegated to the fringes of science fiction, has rapidly become reality thanks to breakthroughs in thermoelectric materials, substances that can convert small differences in temperature directly into electrical energy without moving parts or external fuel, enabling a form of energy harvesting that turns your own warmth into usable electricity. And this isn't theoretical or abstract. It's already being done with wearable sensors, implantable monitors, and even skin-like electronics that use the temperature difference between your body and the surrounding air to generate continuous low-voltage power, enough to run heart monitors, glucose sensors, or even tiny communication devices without batteries, wires, or recharging. And the implications of this are enormous, not just for medical technology, but for how we think about the body as a power source. Because every minute your cells are metabolizing fuel, they're releasing heat, roughly 100 watts of thermal energy at rest, equivalent to a small light bulb. And most of that energy dissipates into the environment unused, like steam from an old engine. But if captured, even a fraction of it could be redirected to power-critical tools, extending battery life, reducing size, and enabling devices to function in remote, mobile, or implantable contexts, where changing or charging a battery is impractical or impossible. And this has already inspired a wave of research into thermoelectric generators, flexible electronics, and biointegrated circuits designed to conform to the skin or be embedded into tissues, drawing power directly from the body's heat without interfering with its natural rhythms, creating a seamless interface between biology and technology that opens the door to real-time, continuous monitoring of health signals, heart rate, oxygen levels, hydration, brainwaves, and more, without the friction of traditional batteries or the risk of mechanical failure. And what makes this even more revolutionary is that this power isn't harvested through invasive means. It doesn't hurt, doesn't drain, doesn't require extra effort, because the heat is already there, already being produced every second of your life, as a side effect of life itself, meaning your body becomes a power plant you didn't know you had. And this redefines the concept of autonomy, not just in machines, but in humans, because it means the tools that monitor your health or enhance your function could one day be powered entirely by you, closing the loop between sensing and acting, biology and computation, in a way that blurs the boundary between self and system. And as this technology matures, it raises profound questions about the future of medicine, aging, mobility, and what it means to live with machines that are not separate from you, but part of you, running not on external fuel, but on your own thermal rhythm. And what's fascinating is that the physics behind this isn't new. Thermoelectricity was first observed in the 1800s, in what's known as the Seebeck effect, where a voltage is produced across the junction of two different conductors exposed to a temperature gradient. But only recently have materials become advanced enough to apply this principle efficiently at the low temperature differences found on the human body. And now, with nanotechnology and flexible substrates, researchers are creating ultra-thin body-conforming thermoelectric devices that can wrap around arms, wrists, or even internal organs, harvesting energy from temperature gradients as small as a few degrees Celsius, and converting it into power for microcontrollers, sensors, or wireless transmitters. And this development becomes especially critical in settings where access to electricity is limited: rural clinics, disaster zones, space travel, places where medical devices that power themselves using the patient's own heat could transform outcomes by enabling long-term, low-maintenance monitoring or intervention. And beyond healthcare, this approach has potential in the realm of wearable tech, allowing for truly autonomous fitness trackers, sleep monitors, or environmental sensors that run indefinitely without need for charging. And as these technologies become smaller, more efficient, and more integrated with the body's contours, we begin to approach a future where devices don't just ride on the body, They become part of its thermodynamic signature, powered by the same processes that keep you alive. And the elegance of this lies in its sustainability. Because it's not about adding more, it's about using what's already there, turning waste into resource, entropy into function. And in that, it mirrors a deeper truth about nature itself, that nothing is truly wasted, that every output is a potential input, and that intelligence lies not in accumulation, but in circulation, in learning how to catch the energy already slipping through our fingers, and in doing so, redefine how we interact with the world and ourselves. Not as separate from the machines we build, but as their partners, coexisting, co-evolving, and now, co-powering. You can function with half a brain. You might assume that the brain, with its complexity and symmetry, functions like a two-engine aircraft. Remove one side and the system crashes. But biology has a way of defying assumptions. And the truth is both unsettling and awe-inspiring. You can quite literally live with only half a brain and not merely survive, but thrive, think, speak, feel, even grow, because the human brain is not just a machine with fixed wiring, but a dynamic, self-reorganizing, plastic system capable of adapting in ways that seem almost miraculous. And nowhere is this more evident than in a medical procedure called a hemispherectomy, where one entire half of the cerebral cortex, either the left or the right hemisphere, is surgically removed or disconnected to treat severe, life-threatening neurological disorders, such as intractable epilepsy, often in children. And although the idea of losing half your brain conjures fears of paralysis, cognitive collapse, or personality erasure, the reality is astonishingly different. Many patients go on to live functional, meaningful lives with relatively intact language, memory, emotion, and mobility. Their remaining hemisphere rewiring itself over time to take on roles it was never designed for, as if the brain, when faced with absence, chooses adaptation over despair and begins to reconfigure its architecture around what remains, creating new pathways, forging unexpected connections, and demonstrating a kind of resilience that challenges everything we thought we knew about the mind-body relationship. Because if a child can lose their entire left hemisphere, the side traditionally responsible for language, and still learn to speak fluently, what does that say about the rigidity of brain specialization? And what does it reveal about the potential that lies dormant within the half that remains, waiting to be called into action only under extraordinary pressure? And this phenomenon isn't limited to surgical cases. Studies of people born with only one hemisphere, or those with massive early brain damage, show similar outcomes, suggesting that the plasticity of the brain is most profound during early development, when the neural networks are still forming, and the architecture is flexible enough to reassign function on a massive scale, a process scientists call functional reassignment, or neuroplasticity, which means that the brain is not a static organ, but a learning one, constantly updating its map of the body and its understanding of itself. And this becomes even more remarkable when we consider how specialization normally works. The left hemisphere is typically involved in language, logic, and linear processing, the right in spatial reasoning, emotion, and holistic perception. But when one side is removed, the other can absorb many of these functions, though often in slightly altered forms, proving that these boundaries are not fixed but fluid, and that the brain's capacity is not just in its structure, but in its ability to reallocate resources, to adjust to damage, to prioritize survival over symmetry. And this opens a vast field of inquiry into how we understand identity, because if your thoughts, language, and memories can continue with half the brain, then where exactly is the self located? If not in a specific structure, then perhaps in the pattern, the process, the dynamic interaction of cells and signals that define consciousness. And if that pattern can shift across hemispheres, then maybe the self is not a place, but a movement, not a structure, but a rhythm that can relocate when needed, adapt when forced, and flourish even under radical change. And this insight has profound implications not only for neurology and rehabilitation, but for how we teach, how we recover from trauma, how we design AI, and how we relate to people with neurological differences. Because it invites us to see the brain not as a fixed circuit board, but as a living, breathing, evolving ecosystem capable of healing and repurposing itself in response to injury. And this repurposing doesn't happen instantly. It unfolds over months, sometimes years, with the remaining hemisphere gradually taking on functions, aided by therapy, environment, and experience. And the degree of recovery varies depending on age, the location of the damage, and individual variability. But the overarching theme is clear. The brain is a master of reinvention. And even when half of it is gone, the story isn't over. In many ways, it's just beginning. And this reframes our understanding of capacity, suggesting that we may be using far less of our brain's potential than we imagine. Not because it is inaccessible, but because it is dormant, unchallenged, not yet needed. And it raises the haunting possibility that only in loss do we fully discover what was possible all along, that only when one side is silenced does the other learn to sing a new song. And while we would never wish such loss on anyone, the lessons it teaches us about adaptation, resilience, and the distributed nature of function are invaluable, and they echo across fields as diverse as neuroprosthetics, stroke rehabilitation, cognitive therapy, and even the philosophy of mind, challenging the long-held belief that certain faculties are forever bound to certain regions, and reminding us that consciousness may not be tied to geography, but to connectivity, plasticity, and the capacity to change. And in that sense, the half-brain story is not one of deficit, but of potential, a testament to the body's ability to survive the unthinkable, to rewire its deepest systems, to recreate itself from within, and to continue, not just in spite of what's lost, but because of what remains. Your tongue print is unique. You may think of your tongue as just a tool for tasting, speaking, or chewing. An unspectacular, hidden muscle that only matters when food or words are involved. But what if I told you that the very surface of your tongue contains a biological signature so distinctive, so uniquely yours, that not even your identical twin could replicate it? And that this soft, moist, ever-moving part of your body could one day be used to identify you as reliably as a fingerprint, a retinal scan, or even DNA. At first glance, the tongue seems mundane, a fleshy appendage we rarely see and rarely consider, tucked safely behind lips, busy with silent labor. But beneath its unassuming exterior lies a complexity that most people never consider. Thousands of papillae, ridges, valleys, and salivary structures, arranged in patterns determined by genetics, shaped by environment, and stabilized by time, forming a topography so personal that it remains remarkably stable over years, despite constant use and exposure. Its ridged terrain, moistened, textured, alive, is like a living map, carved not by rivers and mountains, but by biology and experience. And unlike other biometric markers that can be altered by scarring, injury, environmental conditions, or cosmetic manipulation, your tongue is protected, enclosed within the vault of your mouth, less prone to tampering, shielding its uniqueness beneath a barrier of skin and teeth. This has led researchers to explore the fascinating and still emerging field of tongue biometrics, a discipline that merges anatomy forensics, neuroscience, and computer vision to analyze the unique geometry, texture, and movement patterns of each individual's tongue. Using 3D imaging, infrared analysis, and AI-driven recognition systems to verify identity with startling accuracy. It is a fusion of technology and biology so seamless that it almost feels futuristic. And yet, it is already here. Tongue recognition systems are being prototyped for applications ranging from personal security to forensic investigations, especially in contexts where fingerprints may be unavailable or faces obscured. What's even more remarkable is that this uniqueness isn't just skin deep. The tongue is both muscular and vascular, innervated with nerves that shape not only how it moves, but how it feels, how it flexes, how it rests, how it vibrates during speech or contracts when we swallow. These behavioral and functional nuances are deeply personal, shaped by years of habit, speech patterns, dietary preferences, and even subtle emotional states. In other words, your tongue doesn't just look like no one else's, it acts like no one else's. And this opens an entirely new dimension of identity. Because it's not just about anatomical structure, it's about the choreography of motion, a living dance of musculature and sensation. And no one performs that dance quite the way you do. This means the tongue becomes more than a piece of anatomy. It becomes an evolving record of self, a hybrid between blueprint and diary. From a biological standpoint, this makes perfect sense when you consider the tongue's multifunctional roles. Not only does it manipulate food, produce speech, and detect taste, it's also a sensitive sensory surface with rich innovation, playing a crucial role in how we interpret the world through texture, temperature, pain, pressure, and flavor. Its connection to the brain is intimate. Tongue movements are tied to language centers, motor planning, and even emotional expression. Think of how your tongue clicks in frustration, curls in concentration, presses against your teeth in hesitation. Each of these micro-movements is unique to you, like the subconscious flourishes of a signature, because the tongue is so deeply integrated with both sensory and motor systems. Its development is shaped by countless micro-experiences. What you eat, how you speak, how you sleep, and even your emotional states, all of which subtly influence the way your tongue grows, functions, and behaves, embedding tiny, invisible variations that add up to a signature no one else shares. And this uniqueness isn't just theoretical. It has practical applications that reach far beyond scientific curiosity. In the world of secure authentication, scientists are exploring how tongue prints could be used in environments where fingerprints are compromised. Wet conditions, medical settings, or places requiring high levels of hygiene and security. A soldier in a battlefield, a diver underwater, or a surgeon in a sterile room might one day verify identity, not with a retina or thumb, but with a quick scan of the tongue. And in clinical medicine, tongue imaging is already a growing field. Not just in traditional Eastern practices, where the tongue is believed to reflect internal balance and organ health, but in modern approaches that use machine learning to analyze tongue coloration, coating, movement asymmetry, and vascular changes as early indicators of systemic diseases. Conditions like diabetes, Parkinson's disease, anemia, and even some cancers leave early, subtle traces on the tongue, often before external symptoms appear, making the tongue not just a passive reflector of health, but an active diagnostic tool. And if all this sounds speculative, consider this. Artificial intelligence models trained on thousands of tongue images have already demonstrated the ability to identify a range of health issues, with surprising reliability suggesting that this humble muscle may hold not only our identity, but real, time snapshots of our internal state, like a biological dashboard always on display, but rarely examined. Some researchers envision smartphone-compatible tools that could allow users to scan their own tongues and receive early warnings of disease, nutritional deficiencies, or neurological changes, long before they become clinically obvious. Imagine a future where a subtle change in your tongue's surface cues you into a condition you wouldn't otherwise catch for years. All of this leads to a deeper, more philosophical realization, one that transcends biology and technology. This organ we so often ignore, that we rarely see, rarely examine, and often take for granted, may be one of the richest and most personalized data sources in the human body, combining biology, behavior, emotion, health, and history into a single dynamic structure that speaks volumes about who you are and how you are. Whether you are paying attention or not, it reminds us that identity is not only carried in our thoughts or our outward appearances, but etched into the very folds of flesh we use to speak, eat, taste, and feel. It suggests that what makes you you might reside not only in your memories or your face, but in the moist valleys of a muscle you never see in the mirror. It invites deeper questions too. If something as specific as your tongue is utterly unique, down to the way it wiggles when you pronounce a word or tenses before a swallow, what does that say about individuality more broadly? About the myth of sameness? About our tendency to flatten identity into categories, labels, and generalized types? What if every piece of us, visible or not, is bursting with detail, silently defying replication, insistently real? What if sameness is the illusion, and difference is the rule? Perhaps we've been looking for the soul in the wrong places, imagining it as some invisible light deep within the brain or the heart, when in fact it's been right here, humming quietly in the body's ordinary functions, in the swirl of a fingerprint, in the rhythm of your gait, in the shape and shadow of your tongue. It's a humbling reminder that the body, even in its smallest folds, holds mysteries that science is only beginning to hear. And so, the tongue is no longer just a muscle. It's a canvas of selfhood, a biological sculpture shaped by heredity and honed by experience, a mirror not just of taste and speech, but of movement, emotion, memory, and even disease. It whispers who you are in every word you speak and every flavor you sense. And whether you notice it or not, it is always there, moving, tasting, flexing, reacting, recording. It's your silent witness, your intimate companion, your living seal of individuality. And the next time you speak, or savor a taste, or feel the press of your tongue against the roof of your mouth, remember, you are engaging with something profoundly yours, something no one else has ever truly had, and no one else ever will. Emotions influence body temperature. You probably associate body temperature with external conditions, hot days, cold nights, fevers, or maybe workouts. But what if I told you that your inner climate is not governed solely by the weather or by illness, but by your feelings, that your emotions, those intangible flickers of fear, joy, shame, love, and anxiety, are constantly reshaping your physical heat map, sculpting your thermal signature in ways so precise and consistent that scientists can map them, read them, and sometimes even predict them. And that beneath your skin lies not just blood and bone, but a dynamic landscape of warmth and chill that responds immediately to your psychological state, shifting like a mood ring made of living flesh. And this isn't metaphor. It's measurable, quantifiable, and deeply embedded in how the human body expresses itself. Because emotions are not abstract. They are physiological events, complex cascades of neural, hormonal, and metabolic changes that ripple through your autonomic nervous system and touch everything from your breathing to your digestion to your temperature regulation, with each core feeling, anger, fear, happiness, sadness, surprise, generating distinct thermal patterns across your face, torso, limbs, and extremities, as if your body is painting its inner state across its outer surface in invisible ink. And this connection between emotion and thermoregulation is so fundamental that it has been observed across cultures and ages, with studies using infrared thermal imaging confirming what poets and philosophers have intuited for centuries, that we feel a flush of embarrassment, a chill of fear, a warmth of affection, or a cold shoulder for real physiological reasons. And that these aren't just figures of speech, they reflect actual, measurable shifts in blood flow, vasoconstriction, and heat distribution triggered by the brain's interpretation of emotional stimuli, with the hypothalamus acting as a central command center, translating your psychological state into thermal action by dilating or constricting blood vessels, activating sweat glands, adjusting heart rate, and even modulating muscle tone, all in an effort to help you respond more effectively to whatever emotional context you're in. And the more you explore this connection, the more profound it becomes, because it reveals that emotions are not confined to the brain. They are full-body events, written not only in facial expressions and gestures, but in micro adjustments of temperature that reflect your inner world in real time, whether you notice it or not. And what's particularly fascinating is that this thermal response is both automatic and precise. When you feel anger, for instance, heat often surges to the upper chest, head, and hands, preparing you for confrontation. When you feel fear, heat drains from the limbs as blood is rerouted to core organs in anticipation of danger, producing the sensation of going cold. When you experience happiness, a gentle warmth spreads across the body, particularly the chest and face, while sadness tends to produce cooling, especially in the limbs, contributing to the sensation of heaviness and withdrawal. And researchers mapping these emotional thermographies have found that people across cultures, languages, and backgrounds report remarkably similar experiences, suggesting that these responses are not just learned. They are biologically wired, evolutionary adaptations that once helped our ancestors survive by preparing the body for action in sync with the emotion being felt. And in the modern world, where many emotional responses no longer correspond to physical threats, these temperature shifts still occur, often unnoticed, sometimes chronic, and occasionally dysregulated, contributing to patterns of anxiety, fatigue, or emotional burnout that we struggle to explain. And this opens a whole new dimension of self-awareness, because understanding your emotional thermal connection allows you to tune into your body in subtler ways, noticing not just your thoughts or behaviors, but the microclimates they create within you, offering insight into how your body copes, resists, and adjusts. And this awareness is not just academic, it can be transformative, because recent studies have shown that practicing techniques like mindfulness, controlled breathing, and biofeedback can influence these thermal patterns, allowing people to regain control over stress responses, reduce chronic inflammation, and even shift mood by deliberately altering their body temperature. Through behavioral intervention, such as placing warm hands on the chest to invoke feelings of comfort, or using cold exposure to calm racing thoughts. And this feedback loop between feeling and physiology is a powerful tool, one that challenges the outdated notion of a mind-body divide and replaces it with a model of dynamic integration where every emotion leaves a thermal trace. Every mood has a climate, and your body is both thermometer and thermostat, both sensing and shaping how you feel in every moment. And if we push this idea further, we can begin to imagine a future where wearable devices monitor emotional temperature in real time. Not metaphorically, but literally, alerting you to rising stress, helping guide therapy, or even improving interpersonal communication by revealing unspoken affective states through subtle heat maps. And while that might sound futuristic, the science is already here. With affective computing, emotional AI, and thermal imaging, converging to create systems that read emotions not through words or facial expressions alone, but through the body's most primal, honest signal, its heat. And this reframes the very nature of emotional expression, positioning it not as something that only happens in language or art, but as a physiological signature that your body writes across its own surface every moment of every day. Whether in joy, grief, rage, or awe. And when you start to see it this way, your own sensations begin to make more sense. You realize that the shiver down your spine isn't meaningless. The warmth in your chest isn't just poetic. The cold in your hands when you are nervous isn't weakness. It's communication, an ancient biological language spoken in blood vessels and thermal gradients, a language that connects you not only to yourself but to others. Because we are all thermal beings, radiating our inner states to the world, often without realizing it. And perhaps the more we learn to read those signals, our own and others, the more compassionate, grounded, and attuned we become, able to respond not just with logic, but with warmth where it is needed, coolness where it is calming, and awareness where it heals. Because your emotions don't just color your experience, they shape your temperature, and your temperature, in turn, tells a story your words never could. Touch lowers cortisol. You might believe that touch is just a simple gesture, a handshake, a hug, a pat on the back, something polite or affectionate, something nice but not essential. But what if I told you that beneath every touch, every brush of skin against skin, lies a potent biological mechanism capable of reshaping your entire internal state, that a single moment, physical contact has the power to calm your nervous system, rewire your brain, slow your heart, and most importantly, reduce the levels of one of the most corrosive and relentless hormones in your body, cortisol, the chemical fingerprint of stress, fear, and emotional overload, which silently chips away at your well-being. When left unregulated, affecting everything from your memory, to your immune system, to your metabolism. And yet, in the presence of safe, nurturing touch, this invisible biochemical threat begins to dissolve. Your cortisol drops, your parasympathetic nervous system activates, and your body shifts from vigilance to safety, from tension to release, from survival to presence. Not because you made a rational decision to relax, but because touch bypasses cognition and speaks directly to your biology in a language far older than speech, a language that mammals have carried for millions of years, one designed not for logic but for connection. And it's here, in this delicate interface between skin and skin, that some of the most powerful healing mechanisms in the body are quietly triggered, beginning with specialized nerve fibers called C-tactile afferents, found predominantly in hairy skin and tuned not for pain or pressure, but for gentle, caressing touch, the kind you experience in a hug, a stroke of the arm, or a reassuring pat. And when activated, these fibers send signals to the insular cortex, a part of the brain deeply involved in emotional regulation, empathy, and interoception, leading to a cascade of responses that includes the release of oxytocin, the bonding hormone, and the downregulation of cortisol, creating a shift not only in your mental state but in your physiological reality. And what is remarkable is how consistent this response is, from newborns placed skin to skin with their mothers to elders receiving hand massages in nursing homes. The evidence is clear: touch lowers cortisol, and not just in isolated cases, but across cultures, ages, and circumstances, suggesting that this is not a learned behavior or a cultural artifact, but a core biological truth, one that has evolved precisely because of its effectiveness in regulating stress and enhancing survival. Because in the wild, mammals rely on touch not just for grooming or warmth, but for emotional synchronization, for signaling safety and reducing hyperarousal in the face of threat. And humans, though vastly more complex, are no different. Our need for touch is not a luxury or indulgence, but a regulatory necessity, one that begins in infancy and persists throughout life. And when deprived of it, we suffer not just emotionally but chemically, with studies showing elevated cortisol, increased heart rate, weakened immunity, and disrupted sleep in people who lack regular, nurturing contact. And what makes this even more compelling is that the mechanism is not only reactive but preventive, meaning that regular positive touch doesn't just reduce stress in the moment. It builds resilience, recalibrates your stress threshold, and alters your baseline cortisol levels over time, leading to long-term benefits in mood regulation, cardiovascular health, and cognitive performance. And this has been demonstrated not only in lab studies but in real-world applications, from neonatal intensive care units, using kangaroo care to reduce infant stress and improve outcomes, to therapy animals lowering cortisol in trauma survivors, to couples whose regular affectionate contact correlates with better health markers and faster recovery from illness, all pointing to a single elegant truth: touch is medicine, not in metaphor, but in measurable biological terms. And it's more accessible than any pill, more immediate than any therapy, because it requires nothing but presence, intention, and a willingness to be near another human being with gentleness. And yet in modern society, touch is often regulated, stigmatized, or overlooked, particularly in cultures where autonomy and personal space are overemphasized at the expense of human connection, leading to what some researchers now call touch hunger or skin hunger, a chronic, unspoken deficiency in tactile interaction that contributes to widespread anxiety, loneliness, and emotional dysregulation, especially in urban environments, and among vulnerable populations like the elderly, the isolated, and those in institutional care. And if we accept that chronic stress is one of the most pervasive health issues of our time, then we must also recognize that touch, simple, intentional, compassionate touch, is one of the most underutilized solutions, and that reintroducing it into daily life, whether through therapy, relationships, or community practice, may be one of the most effective low-cost ways to improve mental and physical health on a global scale. And the beauty of this mechanism is that it's reciprocal. The person giving the touch also experiences reduced cortisol, increased oxytocin, and enhanced well-being, meaning that kindness expressed through touch is a mutual medicine, reinforcing bonds and strengthening nervous systems on both sides of the exchange. And this is not limited to romantic or familial relationships. It applies to platonic touch, therapeutic touch, and even self-touch, as studies have shown that jigging oneself, placing a hand on the chest, or practicing mindful touch exercises can also lower cortisol and create a sense of embodied safety, reminding us that the body can be both healer and healed, that touch does not require another to be effective, though it becomes more powerful when shared. And this reframes how we might think about trauma, healing, and human connection, not as abstract psychological processes, but as deeply physical ones, grounded in the way our skin communicates safety to the brain, how our nervous system learns calm through contact, and how our stress systems can be gently unwound not through words alone, but through presence, warmth, and care. And so the next time you feel overwhelmed, the next time cortisol builds invisibly within you, and the world feels too fast, too loud, too much, remember that the simplest remedy might lie in a hand held, a shoulder touched, or a moment of stillness in someone else's arms. Because your body already knows how to heal. It's encoded in your nerves, your hormones, your skin, and all it may be waiting for is a moment of connection to remind it that it's safe enough to let go. Tears from emotion have unique chemistry. You've likely felt it, a lump in the throat, a sting behind the eyes, a sudden flood of warmth that gathers and spills over. Not from pain, not from injury, but from something deeper, more complex, more human, a wave of emotion that bursts forth as tears. And while you may assume that all tears are the same, just salty water shed in different contexts, science tells a very different, far more fascinating story. Because tears born from feelings, grief, joy, rage, awe, are chemically and structurally distinct from those triggered by irritants like smoke, or by reflexes like chopping onions. And this seemingly simple act of crying, so often dismissed or hidden or apologized for, is in fact a profound neurochemical event, one that encodes your inner world into molecular form, transforming invisible emotion into visible matter, as if your body, unable to contain the weight of what it feels, spills the truth through your eyes, not metaphorically, but biochemically. And what emerges is not just saline, but a complex solution containing stress hormones, neurotransmitters, proteins, and enzymes that differ depending on why you are crying, revealing that emotional tears are not merely symbolic, but biologically unique, carrying within them the traces of your mental state, your hormonal flux, your psychic overload. And in that sense, each tear is a kind of chemical fingerprint of the moment it was born, a droplet of emotion captured in fluid form. And the idea that feelings could have chemistry may seem poetic or abstract until you look at the data. Researchers studying the composition of tears under microscopes have found that reflex tears, like those caused by wind or dust, are primarily made of water and enzymes like lysozyme to kill bacteria and protect the eye, while emotional tears, those cried during heartbreak, despair, laughter, or even spiritual release, contain additional compounds like adrenocorticotropic hormone, leucine enkephalin, a natural painkiller, and prolactin, the hormone associated with bonding and maternal behavior, suggesting that the body in its infinite wisdom, doesn't just cry for cleansing. It cries to regulate, to release, to soothe itself chemically from within. And this shifts our understanding of crying from something weak or irrational into something deeply adaptive, a psychophysiological mechanism that allows us to offload emotional intensity in ways that are both psychologically healing and physiologically strategic. Because when we cry from feeling, we're not just expressing, we're excreting, lowering our stress hormones through tears, resetting our nervous system in the process. And this may be why people so often report feeling better after a good cry. Not because the external situation has changed, but because the body has chemically shifted its internal state through the act of crying, like a pressure valve releasing steam from a boiling engine. And perhaps this is why humans are the only species known to produce emotional tears. Because somewhere in our evolution, this function was deemed so beneficial that we kept it, refined it, protected it. And though other mammals feel emotion and express distress, none shed tears from sadness or joy the way we do. None transform their inner turmoil into liquid streams of expression that trace the face and fall to the ground as evidence of what cannot be said. And this capacity adds a unique layer to our species. Tears become language, emotion made visible, grief made shared, joy made undeniable. And even though society often shames tears or associates them with fragility, the truth is far more empowering. Crying is not a breakdown, it is a breakthrough. A moment when the inner world becomes too full to remain contained, and so the eyes, those delicate windows to the soul, flood not to blur vision, but to bear witness, to ask for connection, to say without words that something within has shifted, overflowed, reached a point of transformation. And modern imaging has even shown that crying alters brain activity, activating the parasympathetic nervous system, while deactivating threat responses in the amygdala, allowing the body to move from a state of high arousal and emotional chaos into one of relative calm and regulation. And this is why holding back tears can feel like holding your breath, unnatural, straining, misaligned with the truth of the moment. And why letting them fall, even in solitude, can feel like a kind of internal rebalancing, a quiet, sacred return to center. And beyond the neurochemistry, tears have physical structure too. Under a microscope, dried emotional tears crystallize in distinct patterns that differ from those of reflex or basal tears, forming fractal-like designs that some researchers have described as molecular landscapes of feeling. And while this may still be a poetic framing, it reflects a deeper truth, that every tear holds information, a tiny archive of the emotional moment that produced it. And if we could read them like scripts, we might discover not only what someone was feeling, but how deeply, how urgently, how silently they were processing the world within. And this changes how we think about tears, not as weakness, but as wisdom, as an evolved system of release, signaling, and relief that connects biology with biography, cell with story, fluid with feeling. And it opens up broader questions too. What happens in societies or families where crying is suppressed? What toll does it take on the body to feel without release? What chronic stress, what chemical buildup accumulates in those who never let themselves cry, who never let the emotion leave the body through this ancient alchemical process? And could the act of crying, honest, unashamed crying, be one of the most accessible, most misunderstood, and most underutilized tools of emotional health we possess? Because if tears can lower cortisol, release oxytocin, relieve tension, and recalibrate the nervous system, then perhaps we should see them not as failure, but as function, not as breaking, but as balancing. And in doing so, begin to reclaim the emotional intelligence of crying as something natural and even noble. And this reframing matters especially in a culture that so often demands composure, stoicism, and emotional containment, particularly in adults, where the ability to hold it together is praised, while the willingness to break open is seen as loss of control, when in fact the act of crying may be one of the most controlled, most precise emotional responses we have, triggered not by choice, but by need. a need to reset the chemical tides of emotion that otherwise threaten to drown us from within. And if we allow ourselves to feel without shame, to cry without apology, we begin to access the full depth of what it means to be human, fragile, yes, but also self-healing, self-regulating, emotionally responsive systems designed not just to endure, but to process, metabolize, and transform pain into presence, loss into learning, fear into movement, and joy into shared wonder. And so the next time you feel tears rise, know this: your body is not betraying you. It's protecting you, translating the unspeakable into something fluid, honest, and alive, offering a chemical prayer to the nervous system that says, "Let go, you are safe now." And whether those tears fall in the quiet of night, the chaos of grief, the stillness of joy, or the vulnerability of love, they carry with them not just salt and water, but memory, message, and medicine, uniquely tailored to the moment, uniquely yours, and worth honoring every time they appear. Your body has magnetite. You probably assume your body is governed by biology and chemistry alone: cells, hormones, genes, and neurotransmitters, forming the foundation of thought, movement, and feeling. But quietly embedded in the deepest layers of your tissues, tucked within your brain and scattered through your bones, exists a mine. Most people associate with compasses and geology, not consciousness, magnetite, a naturally occurring magnetic iron oxide with the rare property of forming crystals that can align with Earth's magnetic field. And though it sounds like science fiction or some spiritual metaphor, this mineral is physically present inside you, in measurable quantities, serving no structural role, no mechanical purpose, and yet it persists, as if your body has held onto this ancient compass, not by accident, but by evolutionary design. And the more we study it, the more we realize that the human body may not just live on Earth. It may be tuned to it, subtly sensitive to the planet's magnetic whispers, in ways we're only beginning to understand. Because magnetite is not just a passive remnant of iron metabolism. It's biologically formed, crystallized into nanoparticles that are magnetically responsive, and found in especially high concentrations within the ethmoid bone, just behind your eyes, and within the tissues of the brain itself, particularly near the meninges and pineal gland, regions long associated with orientation, sleep regulation, and subtle sensory processing. And this strange presence isn't limited to humans. Magnetite has been discovered in birds, bees, whales, fish, and even bacteria, with many of these species using it to navigate vast distances, orient during migration, and detect geomagnetic shifts, suggesting that magnetoreception, the ability to perceive magnetic fields, isn't some mythical sixth sense, but a very real sensory modality that has quietly threaded its way through the evolutionary tree. And while most animals appear to rely on it instinctively, the human relationship to magnetite remains more enigmatic, less overt, more subconscious, raising fascinating questions about what exactly this mineral is doing in our heads, and whether it still influences us in ways that lie just beyond conscious perception, operating beneath thought, like a compass we don't know we're holding. And experiments have begun to hint at this possibility. Some studies suggest that weak magnetic fields can subtly alter human brainwaves, that exposure to geomagnetic fluctuations may affect mood, cognition, and even circadian rhythms. And that certain individuals, particularly those with high sensory sensitivity, exhibit measurable physiological changes in response to controlled magnetic stimuli, changes in alpha wave activity, changes in reaction time, even changes in melatonin production. And while the evidence is still emerging, it opens the door to an entirely new understanding of embodiment, one in which you are not only electrically alive, but magnetically alive, woven into the magnetic ecology of the planet through microscopic crystals. Your body chose to grow, and these magnetite particles are not randomly distributed. They are organized in chains and clusters, positioned within cells in ways that suggest intentionality, not accident. And some researchers have even hypothesized that they may interact with mechanically sensitive ion channels in neurons, subtly influencing how signals are fired, how the brain calibrates its internal map of space, or how biological rhythms synchronize with environmental cycles. And if this proves true, then the implications are profound. It would mean that the Earth's magnetic field is not just a navigational tool for ships and birds, but a background signal your nervous system has always been listening to, shaping your sense of orientation, your perception of time, and perhaps even your emotional equilibrium. Because magnetic fields are not just spatial. They fluctuate with solar activity, with lightning, with planetary tides. And if your body can detect those fluctuations, even faintly, then your inner state may be more connected to the sky and earth than you've ever imagined. And this raises deeper questions still. Could ancient humans, less shielded by metal, concrete, and electricity, have been more magnetically attuned? Could magnetite have once played a larger role in orientation, intuition, or altered states of consciousness? Could rituals, dreams, or even the migratory patterns of early tribes have been influenced by a sensitivity that modern life has dulled but not erased? And is it possible that people today who feel drawn to certain places, who experience inexplicable clarity near ley lines, or who find themselves disoriented during geomagnetic storms, are not imagining things, but perceiving something real? An echo of magnetoreceptive capacity that science has only recently begun to revalidate after centuries of skepticism. And as researchers use increasingly sensitive magnetometers and neural imaging tools to study these phenomena, more clues emerge. Experiments showing that even simple magnetic pulses can influence perception, that brain cells containing magnetite may act as biocompasses, and that the pineal gland, long considered the mysterious third eye, in both ancient texts and fringe science, contains calcite microcrystals structurally similar to those in birds' beaks used for navigation, perhaps enabling a form of internal sensing that we've lost the language for, but not the hardware. And this convergence of biology, physics, and forgotten instinct invites us to look at the body with new eyes, not as a sealed, isolated system, but as a resonant participant in the Earth's magnetic orchestra, a living conductor of mineral intelligence encoded in matter. And this perspective dissolves the artificial boundary between organism and environment, showing that you are not merely on the Earth, but of it, built with its materials, responsive to its rhythms, and embedded with crystals that don't just reflect geological time, but may participate in real-time sensory processes that we are only beginning to name. And whether or not this magnetoreception contributes meaningfully to human cognition today is still under investigation. But the presence of magnetite alone forces us to question long-held assumptions about what it means to perceive, to navigate, to know where you are, not just geographically, but existentially, and invites a reconsideration of ancient wisdom that spoke of alignment, of grounding, of cosmic sensitivity, not as metaphor, but as misunderstood expressions of literal physiological capacities that modern culture has overwritten, but not erased. And in this light, magnetite becomes more than a biological curiosity. It becomes a bridge, a clue, a relic of sensory potential waiting to be remembered. And the next time you feel drawn to a place without knowing why, the next time your body feels unsettled under a shifting sky, the next time a storm brews and your sleep breaks without cause, consider this. Perhaps you are not overreacting. Perhaps you are not imagining it. Perhaps you are listening, not with your ears, but with the iron in your bones, the compass in your skull, the mineral memory of a body that has always known where it stands on the Earth, even when the mind forgets. Your immune system remembers every infection. You might think your body forgets the battles it's already survived, that once an illness passes, the chapter closes and everything resets. But hidden beneath your awareness, deep within the architecture of your blood, your bone marrow, your lymph nodes, and even your skin, a vast and astonishing memory system is silently recording every microbe, all encounter, you've ever faced. Not with words or images, but with living blueprints of biological warfare. Because your immune system is not just a reactive force that fights infection in the moment. It's an adaptive, evolving intelligence that learns, stores, recalls, and even refines its response based on the pathogens you've encountered throughout your life. And it does this not by accident but by design, constructing a library of immunological memory that allows it to recognize old enemies in milliseconds, mount a stronger defense before symptoms even begin, and update its strategies like an internal database of everything you've ever survived, from the viruses that caused your childhood fevers to the bacteria you fought off last month, without ever knowing. And this memory isn't metaphorical. It's molecular, housed in a specialized population of cells called memory T cells and memory B cells, each one trained during the original infection, each one imprinted with the molecular signature of the invader it defeated. And what's even more remarkable is that these cells can remain dormant in your body for decades, circulating quietly, waiting with eerie precision for the return of their specific target, ready to reawaken and launch a targeted assault that often neutralizes the pathogen before you even feel sick. Which is why, in many cases, you don't get the same illness twice, and why vaccines work at all. Not because they kill the virus in real time, but because they train your immune system to remember, to simulate an infection, and prepare a memory so that if the real threat ever appears, the defense has already been rehearsed. And this process is so refined that memory B cells can evolve between infections, mutating their antibody genes to better match the enemy, a process known as affinity maturation, making your immune memory not static but dynamic, improving its aim over time, adapting not just to the original form of a pathogen, but even to slightly mutated versions of it, like the annual flu strains that shift subtly year by year. And this evolutionary intelligence is not just passive. It's deeply strategic, organizing your defenses into two layers: the innate immune system, which responds quickly and broadly to any perceived threat, and the adaptive immune system, which tailors its response with surgical precision based on prior exposure. And this dual structure ensures that you are never fighting blind, never starting from scratch, but instead relying on a growing arsenal of immunological experience that follows you for life, and perhaps even beyond, since some research now suggests that parts of the maternal immune memory can be passed to offspring through antibodies in breast milk, giving newborns a temporary shield of protection forged from their mother's encounters. And this reveals an even deeper level of continuity. Your immune system is not just a record of your own life, but a reflection of your lineage, a living archive of survival written in cells, inherited not just genetically, but immunologically. And the implications of this are vast, because it means that every cough, every fever, every scraped knee and stomach bug is not just a moment of discomfort, it's an entry into the book of you, a biological imprint that your body keeps long after your mind has forgotten. And while we often talk about memory as something tied to neurons and consciousness, the immune system reminds us that memory also lives in tissue and time, that remembering isn't just about thought, it's about readiness. And this biological preparedness is why certain diseases are milder the second time around, why booster shots can extend immunity, and why immune therapies for cancer or autoimmune disease often rely on teaching or retraining the immune system to forget or recognize more accurately, because sometimes that memory, so useful in fighting infection, can misfire, mistaking the body's own cells for enemies, launching attacks that result in chronic illness, inflammation, or self-destruction, as in diseases like lupus, multiple sclerosis, or rheumatoid arthritis. And this reveals a painful truth. The immune system's memory, while powerful, is not perfect. It can be fooled by mimicry, overwhelmed by novelty, or stuck in loops where the wrong target is remembered too well. And in such cases, the very same mechanisms that once protected you can turn inward, leading to years of misdirected war within your own tissues, which is why current research into immunological tolerance, immune checkpoint regulation, and memory cell editing is so critical. not just to prevent disease, but to unlearn cellular patterns that have gone awry. And yet, despite these flaws, the immune memory remains one of the most astonishing examples of biological intelligence we've ever discovered, capable of remembering a single protein structure from a virus you encountered in childhood, capable of differentiating between millions of pathogens with exquisite specificity, and even capable of retaining the capacity to respond decades later, as seen in survivors of certain infections like measles, smallpox, or even SARS, whose memory T cells remain active long after the Treat has vanished from public concern, showing that your immune system does not follow the news cycle, does not forget with time, but keeps watch year after year, silently guarding you based on a history you cannot consciously access. And if we zoom out, this reveals a breathtaking metaphor. Your body, without your permission or awareness, is constantly writing its own story, chronicling every invisible war it's ever fought. Not with ink, but with cells. And not in books, but in blood. And every time you encounter a new challenge, whether viral, bacterial, or environmental, that story grows richer, deeper, more complex, as your immune system expands its memory, redefines its definitions of self and other, and becomes ever more precise in how it protects you. And this living archive is not housed in one place. It's distributed throughout your body, in your lymphatic system, your gut, associated lymphoid tissue, your spleen, your thymus, your bone marrow, and even in resident memory T cells that stay embedded in specific tissues, like the lungs, the skin, or the gut lining, stationed like local watchmen prepared to act the moment their specific threat returns. And their presence means that your immune system is not just remembering in theory, it's positioning its memory tactically based on where the attack happened before, ensuring that the second encounter is not just faster, but more geographically accurate. And this level of detail, this cellular choreography of remembrance and response, should force us to rethink what it means to be healthy. Because health is not the absence of conflict, but the mastery of response. And your ability to survive is not built on avoidance, but on the resilience of memory. On the immune system's tireless, often thankless work to log everything you've endured and build a living map of how to survive it. Again, better. And this reframes your body, not as something fragile or blank, but as something deeply experienced, quietly scarred, and immensely capable. A memory machine of flesh and blood that remembers even when you do not, that adapts even when you're unaware, and that protect you not out of instinct, but out of knowledge won through every past confrontation. And so the next time you think of memory, don't limit it to your thoughts or your recollections. Think of your immune system, silently remembering every pathogen that touched your life, every fever that once burned through you, every antibody that was ever forged in fire, now flowing invisibly through you like a whisper of all the victories your body has already won. Sleep position affects brain drainage. You might assume that once you fall asleep, your body powers down like a dimmed machine, resting uniformly in any position that feels comfortable, that what matters is how long you sleep, not how you sleep, but buried within the folds of your brain, flowing quietly through its intricate channels as you lie still in the dark. A hidden system is working tirelessly to cleanse, repair, and renew the very organ that houses your mind. And this system, known as the glymphatic system, doesn't function the same in every sleep position. In fact, the way you lie while you sleep may dramatically affect how efficiently your brain is able to drain itself of toxins, cellular debris, and waste proteins that accumulate during the day, meaning that something as subtle as favoring your right side, your back, or your stomach could influence not just your comfort, but your long-term neurological health, cognitive clarity, and risk of developing neurodegenerative disorders like Alzheimer's or Parkinson's, because unlike other organs that rely heavily on the lymphatic system for waste clearance, your brain uses its own specialized network, a recently discovered pathway that depends on cerebrospinal fluid, CSF, flowing along the outside of blood vessels and into the brain tissue, where it mixes with interstitial fluid and sweeps away harmful byproducts. And this mechanism, termed glymphatic, because of its reliance on glial cells and its resemblance to the lymphatic system, is most active during deep sleep, especially non-REM slow-wave sleep, when brain cells shrink slightly to create more space for fluid exchange, allowing for an intensified flush of waste out of the brain's parenchyma, a process that researchers now believe is critical for maintaining neural health over the long term. But here is where sleep position enters the equation in an unexpected and profound way. Imaging studies in animals and humans have shown that the lateral side, sleeping position appears to facilitate significantly more efficient lymphatic clearance compared to sleeping on the back or stomach, with the left side possibly offering the most benefit due to anatomical and circulatory factors, including the direction of venous drainage and the asymmetry of certain brain structures. And what this means is that the very angle at which your head tilts toward gravity may affect how effectively your brain is cleaned each night, much like how tilting a bowl determines whether the water drains or stagnates at the bottom. And considering that lymphatic clearance removes not only daily waste, but also long-term accumulations of beta, amyloid, and tau proteins, hallmarks of Alzheimer's pathology, this tiny detail of body posture during unconsciousness takes on enormous significance, turning something as ordinary as your preferred sleeping side into a variable of neurological maintenance and even potential disease prevention. And yet most people are completely unaware that their nightly pose could impact the health of their most vital organ. Never taught that the mechanics of rest involve more than just silence and darkness, that gravity continues to shape biology even when awareness fades. And this discovery rewrites long-held assumptions about sleep hygiene, suggesting that not just quantity and quality, but also geometry matters, that the brain's plumbing system, delicate and pulsing, with cerebrospinal fluid, responds to physical posture in ways that alter its function at the most microscopic and consequential levels. And what's even more fascinating is that this phenomenon has parallels in evolution and animal behavior, with many mammals, including rodents and primates, naturally favoring sleeping positions in the wild, perhaps because this instinct was selected for over generations due to its subtle impact on cerebral health, a kind of survival intelligence encoded not in the conscious brain, but in the body's relationship with the Earth's pull. And these insights are transforming neuroscience, inspiring new approaches to sleep medicine, aging research, and even post-operative care, with clinicians beginning to advise specific sleep positions for patients recovering from brain injury, stroke, or surgery to enhance lymphatic flow and accelerate healing. And it goes even deeper. Sleep position may also interact with breathing patterns, blood pressure regulation, and cardiac output, all of which influence cerebrospinal fluid dynamics. And this suggests that the body during sleep is not passive but orchestrating an intricate choreography of position, flow, and pressure to optimize its nightly repair, and the implications stretch beyond neurodegeneration. People with sleep apnea, for instance, often sleep on their backs, which may not only worsen airway collapse but also reduce lymphatic efficiency, compounding cognitive effects over time, while chronic pain sufferers or individuals with mobility issues may find themselves trapped in positions that inadvertently limit brain drainage, unaware that their discomfort is not only disrupting rest, but inhibiting one of the brain's most essential cleansing processes. And in an age where sleep quality is declining and neurological diseases are rising, the idea that such a simple behavioral intervention, adjusting how you lie in bed, could offer a protective effect is both humbling and empowering, because it reminds us that not all solutions are pharmacological or technological, that sometimes the most profound changes begin with small adjustments to forgotten habits. And when you understand the lymphatic system's dependence on sleep depth, posture, and rhythmic pulsation of blood vessels and CSF, you begin to see your nightly rest as a kind of maintenance ritual, one in which your brain literally washes itself in waves, clearing out the mental detritus of thought, inflammation, and protein buildup, restoring the neural landscape for another day of consciousness. And knowing this, you might start to think differently about the moment you lie down at night. Not just as an end to the day, but as an opportunity to aid your body in its most elegant and essential self-care. A chance to tilt your head, not just toward comfort, but toward better drainage, better clarity, better future cognition. And in this light, the mattress, the pillow, the alignment of spine and neck, and even which side you favor, are no longer mere preferences. They are tools, and each night becomes a quiet collaboration between you and gravity, between sleep and flow, between anatomy and time. And perhaps this knowledge reawakens something older in you, something mammalian, a forgotten awareness that how you curl under the covers speaks to your biology, to your long-term health, to the unseen rivers of fluid and impulse beneath your skull, whispering that even in your stillest hours, position matters, and the body, if aligned just right, will clean the mind without ever waking you to say it's done. Yawning may cool the brain. You've probably yawned today. Maybe just once, maybe 10 times, without giving it a second thought, chalking it up to tiredness, boredom, or habit. That slow, involuntary intake of air that stretches your jaw and waters your eyes, often contagious, almost always ignored. But what if I told you that yawning might be doing something far more essential than signaling fatigue or social disinterest? That deep inside your skull, in the folds of your living, breathing brain, yawning might actually serve as a natural cooling mechanism, a neurological air conditioner triggered, not by your feelings but by your temperature, delicately regulating the heat of your most vital and heat-sensitive organ. Because unlike muscles or skin, the brain operates within a narrow thermal window. Even slight increases in core brain temperature can alter neural function, slow cognition, affect mood, and throw off the delicate electrochemical balance required for thought, memory, and awareness. And yawning, as it turns out, is not just a sleepy sigh, but a complex thermoregulatory behavior involving blood flow, cerebrospinal fluid shifts, jaw muscle tension, sinus air movement, and the sudden influx of ambient air through the nasal and oral cavities, all converging in one seemingly simple reflex that under the surface may be purposefully cooling the brain like a fan blast in a stuffy room. And the evidence for this goes beyond theory. Scientists have found that people yawn more frequently when ambient temperatures rise to match or slightly exceed body temperature, when cooling becomes necessary, but that yawning decreases when temperatures are too cold or too hot for effective heat exchange, suggesting that the reflex is not about sleepiness at all, but about thermodynamic optimization. And in this view, yawning is less a symptom and more a tool, triggered when cortical heat surpasses an optimal threshold, prompting a coordinated physiological response designed to quickly draw in cooler air, flex the muscles surrounding blood vessels in the head and neck, and encourage increased venous return from the brain, essentially flushing out warm blood while drawing in cool oxygenated flow, like opening a window in a steamy room. And what makes this even more compelling is that this theory aligns with what we already know about the brain's inability to store excess heat, its reliance on constant blood flow for thermal regulation, and its sensitivity to even small temperature shifts, factors that are particularly critical in the frontal lobe, the area responsible for higher cognitive functions like attention, decision making, and emotional regulation, and which may be especially prone to thermal buildup during sustained mental effort, which is perhaps why yawning so often occurs during intense focus, not just when we're tired, but when we're overstimulated or mentally taxed. Not because we're checking out, but because our brain is trying to stay in the game by managing its own overheating. And this thermal theory of yawning challenges the long-standing myths that yawning is merely a sign of boredom or a cue for social synchrony, and instead positions it as a key element in the brain's self-regulatory toolkit, a built-in cooling system operating through biomechanics and behavior, triggered subconsciously when internal sensors detect that conditions in the brain are starting to drift out of optimal range. and this might explain why yawning is so highly conserved across species, observed in birds, mammals, reptiles, and even fish, not as a quirky leftover behavior, but as a vital survival adaptation that helps maintain neural performance across a wide range of environmental and physiological conditions. And in humans, this mechanism becomes particularly important given the heat we generate through prolonged cognitive effort, the artificial environments we often inhabit, and the fact that our brains are already metabolically demanding organs, consuming about 20% of the body's total energy, despite making up only 2% of its mass, which creates a constant challenge of balancing temperature and function. Too much heat, and neurons fire less efficiently. Synaptic connections falter, and mental fog sets in. Too little, and processing slows down. Alertness wanes and mood deteriorates, making fine-tuned thermal control essential for clear, agile thinking and yawning. In this context, is not a failure of energy, it's a maintenance maneuver, a self-initiated reboot, triggered not by the limbic system alone, but potentially involving the hypothalamus, the preoptic area, the brainstem, and a host of autonomic pathways, designed to respond swiftly to rising thermal load. And if that seems excessive for such a small act, consider this. Yawning changes the volume of your pharyngeal space, alters sinus airflow, activates cooling through evaporation on the tongue and airway linings, stretches facial muscles connected to the dura mater and the venous sinuses of the skull, and even modulates intracranial pressure, meaning that this single reflex affects nearly every physical factor involved in brain cooling. And studies using infrared thermography have shown measurable decreases in forehead temperature following yawns, particularly in situations of mild heat stress, providing direct evidence that yawning is not just expressive, but effective. And understanding this transforms the yawn from a symbol of disengagement to a sign of engagement. That your brain is working hard to stay sharp, to preserve performance, to prevent overheating as you push through a task, or navigate a flood of stimuli. And this makes the act of stifling a yawn, as we so often do in social contexts, potentially counterproductive, not because yawning itself is critical to communication, but because it is biologically necessary in that moment to help your brain recover clarity, and suppressing it might delay the thermoregulatory benefits your nervous system is subtly requesting. And this invites a broader rethinking of how we interpret bodily behavior. Not all fidgeting is distraction, not all stillness is focus, and not all yawning is boredom. Sometimes, these micro-movements are signals of internal homeostasis at work, balancing the unseen tides of blood flow, neurochemistry, and thermal equilibrium. Beneath the mask of conscious thought, and the fact that yawns are contagious may even add a layer of group-based thermal calibration, a shared neurophysiological tuning that spreads through populations when environmental or social conditions demand greater alertness, aligning arousal states across individuals through subconscious mimicry. And though that part of the mechanism remains speculative, the idea that a primitive reflex could help synchronize not just brains with their own internal heat, but with each other's speaks to how deeply embodied and interconnected our cognitive processes truly are. And in the years to come, researchers are likely to explore yawning as a non-invasive marker of neurological health, using its frequency, duration, and context as a window into conditions like traumatic brain injury, stroke, multiple sclerosis, and even psychiatric disorders, where thermoregulation and autonomic function are often disrupted. And this could open new frontiers in diagnostics, allowing something as simple and universal as a yawn to become a biomarker of deeper neurological status, and perhaps even a therapeutic tool through induced yawning, cooling devices, or behavioral interventions to help manage cognitive fatigue, heat-related stress, or attention deficits. And if this seems like a dramatic leap from a basic human behavior, remember that many of the body's most elegant systems are hidden in plain sight. That what we mistake for weakness or irrelevance, is often a relic of deep evolutionary intelligence. And yawning, with all its simplicity and mystery, may be just such a system, a quiet recalibration that we overlook, suppress, or apologize for, when in truth it may be one of the brain's most subtle and essential tools for preserving its own clarity. And the next time you feel one rise, not because you're bored, but because your thoughts are heavy and your mind feels warm, perhaps let it come fully and freely, and imagine that somewhere behind your eyes, a wave of cooler blood is making its way through the folds of your cortex. A breeze of clarity, triggered not by will but by wisdom, embedded in your physiology long before you had language to explain it.